All right, hey folks. So yes, we are going to be recording some more today. It is a Saturday. My wife has very kindly offered to take care of the kids and keep them quiet today so that I can get this course done and recorded because, yeah, that would be good to get it all finished. So let me just get this. Oh, whoops. Nope, I don't like that. There we go. Good, good. Yeah, okay, cool. And one second. Sorry, I can share my screen now. I'm just looking, not at this one, but at this one. Where was I? I want to see what it looks like in the browser so we can preserve that. Right there. Okay, yeah. So that was what it looked like. Okay, cool. So we're actually on the next exercise. So it's not super critical that everything look exactly the same. But yeah, pretty good. Persistent volume is what we're on, the step we're on now, but we're going to be working toward the health check, which I believe is just what I can see here. So it's just make the health check endpoint and add the health check HTTP check thing. So let me make sure of something so I can demonstrate the problem this solves. So maybe let's see. Throw our current count let's see, gotta think of how could I break this. There we go. And then fly deploy. Oh, rats. Fly toml. This is that. Oh, okay. The build fails. Yeah, rats. Okay. Let's think of something else we could do that wouldn't result in a build failure, but like the health check would catch. So our health check is basically just going to call this get current count. So we need this get current count to fail in some way that fails the application. I could just do that and say, you know, sometimes weird things happen. The point is, sometimes we write buggy code and we don't want to, it would be nice if we had some way to double check right before deploying that basic things are healthy. And so I'll actually record this as part of the video. See, and it's got, it's going to tell us how many health checks we have here in a second. And we do have one health check. It's the TCP check, just to make sure that it is ready to receive traffic from a networking perspective, but it doesn't actually talk to our app. and the health check will actually talk to the app. That's the idea. Okay, so the server is listening. And then we go here, and it kablooies. If we look at the logs, we've got an unhandled promise rejection. Does it tell us specifically the error? Yeah, here it is. Type error, yada, yada, yada. So it is taking traffic. Our app is down. So then we fix this, get it deployed again. And while that's happening, we add the health check to our fly toml. So this will be services, HTTP checks, and interval grace period. I've got to look up all these things. Whoa, I had 600 seconds after the grace period. Is that what I have in my site? Whoops. Should probably not do that. Let's see. Okay. Whoops, that was wrong. Okay. That is not what I meant to do. Let's see. I'm looking for grace period of 600. That's going to be 5. Yeah, 5 seconds is probably pretty good. I wonder why I set my protocol to HTTP. I'll just try HTTPS. And what the? Is that what I'm doing in my site? Yeah, I don't think we need that. We'll double check that, but I'm pretty sure we can get rid of that. Okay. You know what? I'll just copy this. I'll literally just click that, bring it over and do that and say, feel free to dive in to the config. We're going to make our path be health check. We're going to make it HTTPS. And then we'll come over here and we'll add our health check endpoint. And all this is going to do is get the current count. You can have it do whatever you need to know for sure that your application is healthy. And in our case, that is sufficient for us. And so then we save that. We say fly deploy. Trying to decide if I should deploy it with the health check first. Yeah. Where am I? What the? What? Oh. Oh, right. Yep. I'll need to remember to remove that. Then we fly deploy. Our app is healthy right now. And we can watch the logs here. I guess I'll hang out here and then we'll watch the logs when it says V12 is being deployed. So now we see it's pulling up a new SJC, shut down the old one, bring up the new one. And now it's ready to go. It still hasn't passed the health checks yet, but those will come soon. Sure would be nice if it told you which health checks are passing and which are failing. I wonder if it's not working because I use the protocol of HTTPS. That could be. Yeah, so we'll probably need to just use HTTP. Could be that it's because it's an internal request that's happening, that's not working. So let's try this. Maybe we don't make a health check endpoint. I don't know, kind of like the idea of making a health check endpoint. That's what I do. It allows you to do a lot more. And in fact, in my site, the health check endpoint does make a fetch request to it itself. Maybe I should do that. Ah, man, I really wish that I understood how TOML works. You know what's hilarious about TOML? Tom's obvious minimal language. There's super nothing obvious about this syntax. I have never gotten it, ever. It is not obvious. YAML is better than this. TOML is the worst. These like double brackets, what does that even mean? Why does it have double brackets? Yeah, that's super obvious, Tom. There, yeah, and that's not on here. What's the double bracket mean? Array of tables. Okay, so I suppose we could have another one of these. That's what that is saying, I guess. And so in that case, we could do a slash on home, and then we could do a second one that is a slash on health check. That actually is pretty good. The interval, I'm going to make that shorter. No. We check it every 10 seconds. That's perfectly reasonable. Okay. See what happens if we do that. And in fact, I think I would make this just a head request because we don't actually care about the response for either one of these. Oh, but you know what? That this is expecting a get, so yeah, let's just do a get. It's fine. And then if there's any error in this, then the deploy will not happen, which is the whole point for these health checks, is that it's like a last line of defense before actually deploying. Okay, I'm going to get my 250 steps. I'm going to get all of my 250 steps today. I'm going to get for every hour. So that's awesome. Okay, let's fly deploy with this breakage and make sure that it will not break. Do-do-do. Do-do-do-do-do. Okay, so I'm gonna just sit here and hit refresh a bunch of times. I think that it could be, yeah, so there will be downtime, just by nature of the beast, and we'll get to that, to addressing the downtime. But the fact is that it doesn't deploy a broken app. It's kind of like the last thing you do before your tests. And here, yep, it's still not deployed a broken app. That's the point. It's just like, hold up, we have an app that is no good. And so it's trying to pull it up. It tries it a couple times, and then eventually it will roll back. Yep, and the error is that find first thing. Okay, and here it should say that it's going to roll back. And let's see, where are we at? Okay, just 50 more steps. Okay, so here we got v15 failed due to unhealthy allocations, rolling back to job version 14 and deploying as v16. So this is not a replacement for tests because you don't want to have the application like hanging on people. But the fact is that it didn't deploy something that failed health checks, and so it's like a last line of defense. So that is what we're going to do. So back up everything. Get rid of the health check code here. We'll add that back in a moment. Get rid of this health check stuff. And what I'm going to do is I will add a health check of the home page and just be like, yeah, this is general health check. And then I will also add the health check endpoint, and we'll deploy both of those. Everything's up and going and happy. And then we'll break it and show that it's not going to deploy something that won't pass health checks. Yep, that is going to work. Oh, right, we got to deploy without the health checks. Hope it's kind of interesting to watch the process of creating a video course. It's not easy. Oh, I think I've finished. Yeah, I don't need to bounce around anymore. Yeah, so it's actually not downtime, it's just like stall time during deploys, which we will deal with. Yep, there we go. And it finally resolves. Bum-ba-da-dum. So then I can bump it, and bump it, and do. This is the way we used to do web apps. Just full page refresh on every mutation. Never had to worry about client-side state management. It's beauty. Okay. Okay, here we go. applications that you care about should be tested. And we're not going to get into testing specifically in this tutorial. However, we do have a little bit of a last line of defense that is offered to us by Fly in the form of health checks. In fact, we already have one health check here specifically. It's called a TCP check, which will just make sure that our application is ready to accept network connections, but it doesn't actually connect to our application, make a request, or anything like that. And so what would be really nice is if right before deploying, we could just make a quick HTTP call to our application and say, can you accept traffic yet? And if it responds with a 200 OK, then let's go ahead and deploy the app. And if it doesn't, then let's not deploy the app. Let's keep the old one around and then go figure out why it didn't respond. This is a last line of defense. It's not intended to replace regular testing, but it can be really, really helpful in deploying applications where there's a lot of moving parts and you just want to have just one last little check. So this is called HTTP checks. So if you look up Fly TOML and go to the configuration documentation page, then you can find the services.http checks config. We're going to copy this and bring it over here right below our TCP check. And this interval is just how frequently this HTTP check is going to be made, because it's not just when the application starts, but we want to make sure that our application is healthy over time. And so every 10 seconds, it will just say, hey, are you still healthy? Then the grace period is how long after our application has started up does this HTTP check get called. And I'm actually fine with it being 1 second for this simple application, but some applications take a little while to boot up. And so depending on how long it takes for your application to boot up, you'll adjust that grace period. The method, we can do a GET. You could also do a head request here. We'll just do a GET. We'll do the path just to our homepage. That seems like a pretty reasonable thing that people should be able to get to our homepage, and that should cover a fair bit of ground as a last line of defense. The protocol we're going to leave as HTTP because this is a behind the network request that's going to be happening from a Fly server to our server. So there's no certificate going on there. So we'll leave that as HTTP. Restart limit. This is how many times after a failed HTTP check should Fly just automatically restart the server for you. The default is 0. I'm going to leave it there. And what 0 means is it just disables that behavior. It just will never restart your application once the HTTP checks start happening. Depending on your use case or your situation, you might bump that up to a couple of times. After a couple failures, go ahead and try and restart and just magically maybe it'll work. And then the timeout. So it's making a request to your application. How long are you okay with it waiting to get a response before it decides, oh, it must be failing? So I'll just leave that as 200. Something more reasonable, I suppose, might be 500 milliseconds. It kind of depends on how fast your application responds. The TLS skip verify, this doesn't actually matter all that much because our protocol is HTTP. And then any headers, if you want to make authenticated requests or something like that, you can add headers down here. Okay, so with all of that, let's do a Fly deploy to just get a basic health check out there. And then after this is successfully deployed and it's running, let's go ahead and see what the experience would be like if we actually did deploy something that totally blew up our homepage, for example. So this will speed up here a little bit just to get it deployed, and then we'll give that a test. All right, so here you'll see that it has 2 health checks. Before it only had the 1 TCP, but now we've added our HTTP check, and so now there are 2 of them. And after a while, they're both passing. So if we go and take a look at our application, we can see that it's still running, everything is working just fine, and things are happy. Now, of course, you probably ran your tests as well, hopefully, and so you are pretty confident that things are good. But this just double checks that everything is going to work out. Now, let's make a little mistake here. What if I misspell get right here? That would not be good, and I don't have any TypeScript that's going to double check that that's right. Maybe I should, but let's go ahead and do a fly deploy right now and see what happens as that gets deployed. And let's expand this so we can see all of the output. We'll speed that up for you too. All right, so now we see that we do still have those 2 health checks. One is passing, one is critical, it's not passing. And if we look at our logs over here, we're going to see things are not looking super great for our application. Wait a second, is it going to work? Man, I assumed that would not work. It shouldn't work. Oh, right, we're getting the logs, but it is going to hang. So it's going to fail the timeout. Okay, so I think we can continue from where I say things are not looking great for our application, and I'll explain why. And the reason is, if we look at our code, when we had that typo on get, what happens is it passes this case, it continues down in here, and it's going to give us a 404 not found, which is not going to pass our health check. And eventually, Fly is going to decide, okay, that's not going to fly, literally, and it will roll back to the previous version. So we'll wait for that. I hope it does. I'm pretty sure it does that on a 404. Probably should have checked that before. This is what I get for practicing one thing and then doing another. This does take a little bit of time. I don't think it takes this long. I'm pretty sure this is configurable. Yeah, this is not what I expected to happen. Well, rats. I might have to restart this one. I wonder why. It should be rolling back. Man. Well, it is running every second. Okay, this is a bad example. On my site, if this happened, it would fail because my health check is an endpoint that oh, here we go. Oh, good. Okay, we're gonna continue with this. Let me just make sure we've got these things. Yep. Oh. There we go. Okay. There we go. Okay, good. Okay, so now we can come back here and start up again. I think we had this expanded. Yeah. All right, so with that done, yeah. Great. Okay, so our deploy failed due to unhealthy allocations. So it rolled back to job version 18 and deployed as version 20. So we tried to deploy the version that had the breakage in our index here, where we misspelled get. And that deployed, but Fly didn't actually start sending traffic to it until after the health checks passed. Well, they never passed, and so it actually rolled back and restarted our application with the previous working version, the version that was up before. So it shut down the version that was not working and wasn't able to accept traffic, and it started up a previous version that was working before, and now our application is working. During that time, our application wasn't able to accept any traffic, and there are various deployment strategies that you can employ with Fly that will kind of change the trade-offs that you're making there. But the default strategy with a persisted volume is just, oh shoot, what's it called? I just saw it. It is a rolling, yeah. Let me start that again. Now there are various strategies for deploying with Fly that you can use. There's the rolling strategy, which is the default for a node application that has a persisted volume, and that's the one that we have. But there are other strategies you can employ to reduce the amount of time that your deployment is waiting on health checks. But in our case, the right thing happened. We did not deploy an app that didn't work. We just kind of made traffic hold off while the deploy was happening and while those health checks were being checked. And because they didn't successfully happen, we ended up shutting down the new deploy, starting up the previous version so that we could accept traffic. And then hopefully we get some alerts and say, hey, you know, that deploy did not work. And so you're going to want to take a look at it and figure out what you did wrong. Another thing that I want to do with this is add another health check to make it just really certain that things are working, because you can add multiple of these and that can be quite useful. And for example, on my own personal website, I have a health check endpoint. So we'll do the same thing here, health check. And what this does is it not only will check that I can accept traffic on my home page, but also will make some queries to the database to make sure that the database is in a healthy state as well. So we'll go ahead and add a health check endpoint just here at the top. case, it'll be a GET request to health check. And with this, we'll just do a try catch. And in the catch, we'll, and of course we need to add a break. It's a switch statement after all. In the catch, we'll add a console.error. We'll log the error. And then we'll say res write head 500 and res end. We can do internal server error or just error, whatever you want to do there. But the actual check that we want to do is, let's just say we want to do this query that we're making on the back end. So we'll say await get current count and res write head 200 and res end OK. So we're all set there with those with this health check endpoint. So we can do a fly deploy to get that health check all deployed and ready. And this will also make sure that we have the database ready to go, or you can do whatever else that you want to inside of this health check. And that can be quite useful not only for the health check that's being made by Fly, but also if you ever want to go to your application and just hit the health check endpoint, then you can just make sure that things are running healthily yourself. If you're ever concerned about it, you wake up in a cold sweat, like, is my app healthy? You can always just hit that endpoint and make sure that your application is running in a healthy state. So this is being deployed right now. And as soon as this is deployed, I actually want to test to make sure that this is going to catch something for us. And so what I'm going to do is we're going to add a mistake. Now, TypeScript, of course, is going to catch this mistake for us, but let's just turn that off. Because we do make mistakes on occasion. Not always is it because we turned off TypeScript, but I just want to make sure that this is going to behave properly with this specific health check endpoint. And now you'll see that our health checks, there are 3, and the deploy we just made has 3 passing health checks. So let's add another deploy with what should fail, in fact, both of our HTTP health checks, and make sure that we don't deploy a broken application. So coming over here, the most recent application that we have has been deployed. Everything is good. We look at the logs right here. That health check endpoint and the home page is getting a call every 10 seconds. And so you'll see that in your logs if you have logs set up for every HTTP call that is coming into your app, like we do in this one. Now we're getting a new health check. Oh, let me start that again. Now we're getting a new deploy, so it's going to shut down the machine and start up the new one with our broken change that we just made, and then it will perform the health checks before sending any traffic to it. So if I go to my application now, oh shoot, that is not good. That's not what should happen. Okay, we're going to do a little smoke and mirrors. I think that is wrong. That is not what should have happened. So if I go to the application now, we're going to just have a hanging request while it's waiting to double check those health checks to make sure that everything is all good. Rather than sending the user a bad application, it just decides, hey, we're going to just make you wait until we know that the application is good. And again, we have different strategies that we can employ with various trade-offs that we can have it send traffic to the... let me say that differently. Actually, yeah, we'll talk about all of that later. I think, you know what? I don't even want to bother deploying the new health check. So let's just skip the whole part where we're deploying the health check. I'll just edit that out myself. That way it's not confusing. And so now we have 3 health checks. We've got the TCP health check that came with the initial flytoml that we started with, the HTTP health check for the home page, and the additional health check endpoint that we can do whatever types of health checks we want. Make sure we have connections with the right services, all of that stuff happening inside of our health check endpoint. And that's how you make sure that you don't deploy a broken app to production as a last line of defense. Again, this is not a replacement for tests, but it's a really good last line of defense right before you switch from it is almost deployed to actually being deployed and accepting traffic. Really helpful feature from Fly. Okay. Yeah. We are going to address the whole downtime thing anyway. So that was weird. It should not have done that. It should have just hung, but yeah, it's fine. Here we go. So we're going to go Here, you all can see this, that's fine. I was supposed to take a break during that recording. Whoops. Apply deploy to get that. Okay. With this health check endpoint, so we can do await, get current count, and res right head 200 and res end. Okay. So we're all set there with those with this health check endpoint. It's at least that. Let's just skip the whole part where we're deploying health check. I'll just edit that out myself, that way it's not confusing. Yeah, it was getting long anyway. With this health check endpoint, and so now we have 3 health checks. With those, with this health check endpoint, and so, okay, so we're all set there. I'll just get rid of that. Set there, and so now we have 3 health checks. We've got the TCP health check that came with the initial flight tunnel that we started with, the HTTP health check for the homepage, and the additional health check endpoint that we can do whatever types of health checks we want. Make sure we have connections with threat services, all that stuff happening inside of our health check endpoint. And that's how you make sure that you don't deploy a broken app to production as a last line of defense. Again, this is not a replacement for tests, but it's a really good last line of defense right before you switch from it is almost deployed to actually being deployed and accepting traffic. Really helpful feature for flying. Okay. Ready. Now let's give him a couple more frames if you need them. All right, this is 05, or nope, 06 health check. Okay, cool. We've got our health checks running. Hooray! And we're going to go into all of the all of the things that have health checks, and we got to add those. Whoops. Okie dokie. We're just going to do this temporarily. I don't want to commit that, actually. That would be bad. So untracked files. O2 Docker should not have a fly toml. Whoops. And O1 init app should not have a Docker file either. Yep, okay. Update fly tomls. And what is init fly Docker? What was the change there, I wonder? I think it was this one. Yep, there we go. Yep. Okay. And hold on, what is this change here? Okay, we gotta do this git. Let's look at the diff here. Oh, we've got a console log. Init fly. Okay, so the only things that should change. Yeah, this has the health check in it. We don't want it there. Yeah, it should just be the fly tomls. Persistent volume should not have health checks in it. Get rid of that. Okay, and init fly. The only update was fixing this, I think. Just make sure. Yeah, init fly should not have the mounts. It's hard keeping this stuff straight. All right. So, yeah, that is correct. Yeah, fix all those health checks. All right, cool. Oops. How do you stop recording? I don't know how to do that. Okay. Fix fly health checks. All right. Cool. And then we're going to go back and replace that with the weathered morning so that I don't have to remember to do that. Okay. Great. So coming back here, actually code steps 05. Yeah. And we close this one. We move this one over. We open up the terminal. We get mad that it's not defaulting to the bottom. And we move to the next step. Okay. Boy, that took longer than I expected, but it's good. 05 and 06. What is the diff? Here's what I'm looking at. I'm just doing a get diff no index between the two directories, and it works out great. And the only difference here is we're adding the CLI for the database. So let me just make sure we fly SSH console. And then we can look at everything. We can CD into our app. And there's our app. Cool. And we can CD into our data. And there's our SQLite database. Sweet. And then we can SQLite. And SQLite 3. SQLite. And then we can say tables. Or select star from count. Select star from. Why isn't tables listing out anything? Exit echo database URL. Oh, right, SQLite 3 data SQLite DB. I think it's because I did that that tab thing, then that didn't work. It'll be there. Yep. Select star from count, and there's our count. Dun 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 dun. So wouldn't that be nice? And on top of this, we also have bash. It'd be nice to just jump straight into bash because sh is just not quite enough. So if I exit, and then I say fly SSH console C bash, now I jump straight into bash with the bash command, and we can exit that. So that's cool, but wouldn't it be nice if I could say something like fly SSH console C database CLI? And then have that run. So let's make that a thing. So I don't have to navigate and find the thing and all that. And so we go to our Docker file, and we come down to right below the environment variables, and we're going to create a CLI for us. So we'll just paste that in. So we're going to make the CLI accessible via fly SSH console with that command. And we're going to create this file. So it's a bash or a shell script. Set x. What does set x do? shell set x script. Kind of feel like that should be set xe. I think e would be good to have. Sure, xe. And then we'll run SQLite 3 with the database URL. And then we'll stick that as a new file in user local bin database CLI, and then make sure that is executable. And now we'll deploy that, and this will work. Okay, cool. All right. With a long-running node server, sometimes, let's see, try that again. With a long-running node server and a database, sometimes it can be really nice to be able to dive into that virtual machine, SSH into it, and explore the file system and look at the database. And you can do that with Fly using the fly SSH command, and it will say a fly SSH console to get a console into our running virtual machine. Why is this taking so long? It literally just worked. Okay, speed that up for me, please, I guess. And now that we're connected, let's try this again. And now that we're connected, we can lsal and see here are, try that again. And now that we're connected, we can lsal and see here are all of the directories that we've got. And we know from our Docker file, because we're the ones who created this container, I don't know whether it's a container or an image. Let me say that differently. And now, because of our Docker file, we know that our app is running inside of app, and we also created the mounts config in our flytoml, so we know our database is inside of data. So we could lsal everything in app, and there's our application, and list everything in data, and there's our SQLite database. So things are looking great here. If we now run bash, now we have access to bash and all of the cool things that bash can do, because sh is not quite enough. So don't let me type exit. So we also can run SQLite 3 because we install that as part of our Docker file as well. We do an apt-get to install SQLite 3, and we can interact directly with our database, which is in data SQLite DB. And if we do tables, we can see here are all of the tables. We can select star from count, and there's our count just sitting in our database. We can do whatever database queries that we want to directly in here, and it's really nice to be able to do that, but it's a little bit of work that I don't want to have to do every time I want to look into my database, to have to first run the fly SSH console command and then do SQLite DB. I might forget where that is and all of that. So we're actually going to do a little handy thing inside of our Docker file to make this a bit easier. So in our Docker file, right below where we set up these environment variables, I'm going to paste in this little command that basically creates a new file inside of user local bin database CLI. And that file is going to contain a simple script that uses set xe that'll make sure to print out what is being run and also make sure it has the proper exit code based on the command that's being run here. And then it'll run SQLite 3 across the database URL. So that is the contents of the file that goes into user local bin database CLI, and then we make sure that that is executable. And with that now, we simply deploy this, and then we can run fly SSH console, give it the uppercase C flag for the first command that is executed, and then we run it right into our database CLI. So let's get that deployed. Let me exit this first, and then exit, and we'll say fly deploy. Oh man. Let's exit 0. Here, let's skip all that. It's fine. They don't need to see me exit that. So let's get that deployed with fly deploy. And then I want you to speed this thing up. They don't need to hear me say that we're going to speed it up again. Just like make it really, really fast. Do. Man, there's a lot of waiting when you're doing a course about deploying to environments and stuff. Okay, there we go. And with that deployed now, we can run fly ssh console -c database CLI. And boom, here I am in the SQLite, and I can do tables and select star from count and whatever other SQL commands that I want to execute against my production database. Now, of course, use that with discretion, but it is really nice to be able to jump straight into that using this really simple echo command to create a new file right in our Docker file. So you could do this with any other sorts of commands that you want to be able to easily execute within your Docker VM running on fly. And I think that's a pretty helpful tip. That's just a stupid way to end that. There's no value in what I just said. Let me say that differently. Okay. And that is how you make SQLite. Now let's say that again. And that's how you make the SQLite CLI accessible via the fly SSH console. I literally just read this. Okay, great, that works. So this is 07. What are the words that I'm trying to, yeah. SQLite, what do I call the project? SQLite CLI, SSH, what? Why is this? Come on, hello. What the devil? Good grief. 07 SSH SQLite console. Okay, there we go. Okay, exit, and let's close this one and open steps 06. That is not what I meant. Steps 06. And then we bring up our terminal. We get mad that it doesn't automatically move to the bottom all the time. And we look at our get diff no index between 6 and 07. Okay, so now we add this monstrous GitHub action. Yeah, okay. So the way we're going to do this I think I want to split this up into two parts. The first part is the basic action, and then the second part is supporting a staging environment. Man, config is the worst. I hate teaching config. It is super uninteresting. Yeah, there's something wrong here. I don't think that I need this in here. So we're going to run this on all pull requests to main or dev, but we're only going to run the deploy if we're on main or dev. Yeah, I think that is correct. Oh, whoops. Okay. Okay, this thing on the left side, which one is that? This side, having the file system on this side and the terminal right here, I'm digging it. I like this not moving around ever, no matter what. It doesn't go anywhere. Yeah, before it was going, if I had the left thing up and I remove that and the right thing up and remove that, sometimes it would just bounce all over the place. Not fun. Okay. Yeah, so much of this stuff I don't want to type out. But some of this stuff I think I do want to show. Also, we need to do a smoke and mirrors thing with this, because there's a temporary workaround with that, which is kind of annoying. Community fly. Nope. Oh, and this is going to be even more tricky because I actually need this to be connected to a GitHub repo. Which is, yeah, that just adds a fun layer of interesting complexity to all of this. I don't believe that, I think this is the only one where I need to actually show the GitHub action deploying. Yeah, everything else is fine. So yeah, I only need to worry about this in one instance. So what we're gonna do is I'm gonna create the GitHub repo. I don't need to do that on the recording. People should know how to create GitHub repos. This will be counter app. Okay, and I'm gonna open this. I'm gonna copy that. Close that. Actually, before I do that, let's rename this counter app. Okay, cool. And then we'll init this by itself. Oh, here, let's make sure this has the right name. Weathered morning, yada yada. This is probably what I should have been doing the whole time. Just have a single app, and rather than following the steps. Oh well. That's interesting. Star. Yeah, this part would be interesting because I'm going to show a token. So that will be interesting. Okay, so okay, we got to do this thing now. Provenance. Let's see. This has been failing as well. I wonder if that's the reason. Oh, it was canceled. Ah, that's the reason. Okay. Okay, let's just make sure that this provenance thing works before I try to teach people to use it. I think I'm not going to teach people to use it. Ah, man, that's the worst. Who knows if this is going to be fixed forever or not. Is it bad to use that flag even if you don't need it? Hmm. Yeah, I think we're gonna leave it, keep it in there. Great. Here, I need to sit down. Oh, actually, really quick, I'm just gonna get steps for 12. Come on. I haven't been taking my breaks, so you're gonna watch me take my break. Yeah, so this is the error that happens. So it makes me wonder if maybe we need to have both. Let's do this. Oops. Okay. Just gotta make sure that this can deploy before I try to show people how to do it. Of all things, this is probably one of the hardest courses that I've made because it relies so much on other services and stuff to work properly. Yeah, this is tough. I'll be really happy when this course is finished. And I can move on to other things. This isn't even stuff that I really enjoy that much. I do this out of necessity. Okay, just got like 80 steps left. We can get rid of that. Come on, almost there. 209. Just got 41 left. Get that body moving. Okay, 13 left. Oh yeah, I also probably should double check that I have the latest version of all of these actions, because we get warnings at the bottom that say, hey, you're using old versions of Node and whatnot. We don't like that. Yeah, actions checkout. I believe that there's a new version of that. Oh, yeah, that's probably why it didn't work, because I'm using an old version of that too. Okay, did I make it? Yeah, I did. 4 of 9 hours today. Okay, this hopefully won't take too much longer. I'm pretty sure this is the problem. 2.3. Oh, 17 hours ago, huh? Well, I'm not sure what that's all about. .0.2. And then checkout has, yeah, v3. Okay, well this is actually doing something, so that may have worked. You just need to have both options, which is really annoying. Oh, that's right, I forgot I have multiple regions on this one. Sweet, it worked. Bum-ba-da-dum. And this one's in multiple regions with transactional consistency. Look forward to that. Okay. Cool. Let's see what other things might be old. Okay, nope, not commits. I'm looking at tags. So many tags. All right, so there's a 1.3 of fly control actions, and that's what I'm on. On the cancel workflow is 0.11, that's where I'm at. And build push action, v3 is kept up to date. And that's where I'm at. Yep. The login action is 2.1 or 2. And I think that's what I'm at. Yep. And cache is v3. Yep. Good. So we're on the latest of everything, and it does work as it is. So bump to the latest of all actions. All right, great. So with that in the bag now, I know what my final action config needs to be. Now, how do I teach it? See, this tutorial, the reason this is a tutorial is because it is uninteresting. And these are not skills that you develop. These are things that you reference and you tinker with it to make it work, and then you move on with your life. And so I'm okay with just pasting a bunch of stuff and explaining it. So let's think about how we're going to do this. The counter app is right here. Let's get rid of this. Make sure that this passes. So this one, we got all these warnings. Set output command, huh? Docker build. Okay. So here it took 1 minute and 13 seconds. And then the deploy took 2 minutes 22 seconds. But that's to multiple regions, which will take longer. Well, let's try and remove that and see what happens. Doesn't seem to recognize it anyway. Is that how you spell Providence? Yeah. Oop. Well, so lots of the time I like to make sure we're only teaching what we're teaching and not other things. And so I remove things that are not necessary, like cancel previous runs. That's not really necessary. You definitely need to check out the repo. Reading the app name is not necessary because you could just hard code it. App name. Yeah, okay. I think what we're going to do we're going to make more steps. We're going to call this basic GitHub action. Why do we... Oh, right, so that we can have a cache. Yeah, I think we're going to split this up a couple steps. So the first time we'll have it do the deploy as part of this. And then we'll do GitHub caching, action caching, or cache GitHub action. Hold on a second. This is a big jump from fly deploy to build the Docker image yourself, upload it to their registry. Yeah, it's just a big jump. Let's try this. Here, let's look at what the fly docs. Whoops, fly docs. GitHub actions. Yeah, that's all that they do. Okay. That's it. I think we should just do this. Hmm. I just remember having a conversation with this person. Joshua, that's right, that's his name. Workflow, no, just, yeah. Yeah, I'm pretty sure I'm going to just teach remote only. Just what they do. That's it. Literally copy this. And paste it on that. Mostly. And then for the staging step, I think I do want to talk about how to do this for staging. And so for that, let's look at this here. And we just change the app name to have dash staging. So the final thing, I think the final thing should look like this. But we don't need the build stage. We don't need the pull requests. we get rid of image and instead do remote only. And that's it. So then the basic action, I'm kind of assuming that this is going to work. So let's just add GitHub more basic deploy action. Okay, I'm going to go over here. Why bother with Docker buildx when I built my I guess I should do actions cache. All right, we'll see what people say. But I'm pretty sure I just want to do this much simpler thing. Okay, so what that would mean is the basic action would look like not have staging, would not have this ref thing. It would not have the app name, would not have this if, would not have main or dev. And yep, and it wouldn't have the cancel, checkout, deploy. That's it. Pretty sure that'll work just fine. And then the caching would not be a thing, and instead it would just be staging, GitHub action. And this would have the final thing. It wouldn't have this. And then I suppose we could have a another step that is pull requests, GitHub PRs. So this is going to be 9. This will be 8. Light effect. Here, let's go the other way. This will now be 12, 11, 10. And so then this would have pull request. And then we get this thing back. And we can have a build step to demonstrate that. But it's not going to have cancel yet. You know what? Maybe this one be step 13, 12, 11, and then we'll have a 10. So we don't have cancel. So wait, no, this would be 10, and we will have cancel by now. So that we get basic, and then staging should not have cancel. Okay, and then we bring in cancel. Step 9. Do I really want to do cancel? Is it that critical? You can cancel it yourself if you want. Yeah, we're not going to add cancel at all. And do I care about PRs? No. Yes. You're working on a team. Okay, so this needs to be 09, 10, 11, and 12. So then this one, we're not going to have cancel. We will have this. yeah, I guess. Yeah, we need to do the install step too. Let's see. And setup node. Yep, those 2 steps we'll need. And then here we can say needs build. Okay, cool. So now that supports PRs. We'll run the build, and you can do your tests or whatever else you want to. And that is our final workflow. So then lightfs is going to do that. I hope all this works. Did I push something already? Thought I pushed something to test more basic action. Yeah, let's see. Oh, right. That's right. The root is going to need to do something else. We'll look at that in a sec. Okay. Did I get this one already? Yeah. Okay, so then our root the file is in 12. And then, how did I do this before? I think it's config. Yeah. All right, let's try that. More action steps. Okay. So this is not good. Oh, right. So from the root, we need this down. What is that called? Bombotov npm install. Working directory. Isn't there a way to run commands? npm run in directory. Yeah, whatever, we'll just cd into it. cd 12, oh, steps, we need steps. Whoops. All right. Right there. Okay. Okay, that seems to be working. Hmm. Hmm. What? Okay, so it's cd, maybe this is why. Oh, right, I am in the wrong spot. Okay, well, coming over here then. I just logged into the wrong account. Seems to work okay for this one. Yeah, so that worked okay. We're gonna try something. That's interesting. Well, it works locally. Hmm. That is the same builder, I think. Right? Yep, there, it's the same. Failed to fetch an image or build from source. App does not have a Docker file or build packs configured. I wonder if it's, here, let's try this. Okay, fly deploy. Maybe it's just because we're in the wrong directory. Mm-hmm. That's why. Okay. So it'll work. It's just I gotta figure out how to make this thing work. We're gonna do this a little differently. We'll do this thing. Pretty sure this will work. Okay. Pretty sure that'll work. Get in the right directory. Oh shoot, that's not gonna work. They say at master. We'll just do that. Mm-hmm. Yep, that's what I just fixed. Wow, build is very fast. It's nice. Ah, man. Maybe I need to use flyctl. That would be annoying. Oh, whoops. That would have broken anyway. CTL, there we go. Kind of concerned that that is not what's going to fix it. Let's see what setup flyctl does. JavaScript file, huh? That is... Oh, right, of course it would be, because GitHub Actions. I think this might work. No. Huh. Oh, now it got farther. Oh. That's unexpected. We should have the fly token. I wonder if that... Huh. I think we're kind of in a funny spot. Huh. I don't know what could cause that. But I think I got it. I really want to get it figured out for this repo. Oh, push status stream. Oh, it probably worked anyway. Let's try running this one again, and we'll see what happens if I look at fly logs. That is unexpected. Pushing image to fly. That step somehow doesn't have our auth token, maybe? Okay. Well, dang it. Yeah. Okay, well, we're going to have to stop. I can't have my wife watching the kids all day so that I can record and not record. And I can't record if I am having trouble with getting things deployed. So, let's see. Maybe I should put it here. Okay, well, that's it. I guess we'll just have to figure this out later. Man, I was really hoping to finish this today. It's kind of frustrating. I think this will work. I'm just going to try. I'm just going to go for it. I'm pretty sure this will work. There's probably just something weird with that repo. And if I have any trouble, we'll just call it a day, or whatever they call it these days. Okay, so we're going between 0.6 and 0.7. This is way, way simpler. This is all I have to explain. That is so much simpler than what I had before. Okay, so we're over here. We've got this repo. We've got some stars. What up? Okay, so let's see. Yeah, just need to talk about yeah, what is that command? I always look here. Auth token. Create a new token. How do you get to that? Yeah, access tokens, boom. And then, sweet. GitHub action, create, beauty. And then we're going to revoke it right now so that nobody steals it. Okay, cool. So we'll go to our dashboard. Yeah, that'll be nice and easy. So we'll say we want to deploy our app with there's an airplane. I don't know if, let's see. Yeah, I think you can hear it. So we'll just wait a second for that airplane to pass over. Okay, remind me to take my steps too. It's not counting the steps I just took. I just took a bunch of steps. Come on. Or it's not updating at least. I don't know. Yeah, I just took a whole bunch of steps. It didn't count those. All right, whatever. I'll take steps after this, or maybe while we're waiting for deploys and stuff. Okay, so first we want to, as fun as it is to say fly deploy from my terminal, I want to deploy automatically when I push to a GitHub repo. I've already set up a GitHub repo over here. Yeah, set up a GitHub repo already. And now we just need to create a GitHub action. If we go to actions, I wonder what this does. Yeah, no thanks. That's all right. Okay. Nah, we will not go to that. Okay. And then we just make the folder, the file, and you know what, we'll just paste all this in. There's not much, and nobody wants to watch me type all that ugly config, so we'll just copy and paste it. Okay, here we go. As fun as it is for me to write fly deploy every time I want to oh, good grief. Let's try that again. As fun as it is for me to type fly deploy every time I want to deploy my app, I'd rather just have this integrated with a GitHub repo and have that deploy anytime I merge anything into the main branch. And I've already got the GitHub repo here, so I just need to set up a GitHub action that will do the fly deploy process for me. So we're going to add a GitHub directory with a actions. No, it's not called actions. It's workflows and then deploy YAML. So we're going to make a GitHub directory with a workflows. Let's try that again. So we're going to make a So we're going to So we're going to make a GitHub directory with a workflows directory under that and a deploy.yaml file in here. And I'm just going to paste in a config and we'll talk about it. We've got, this is so annoying, that GitHub workflow, deployer recipe, a JSON schema for deployer YAML recipes, schema.json, or GitHub workflow schema. Yeah, I hate that so much. There's ambiguity. It's not sure which one of these is it is. You know what? I'm sure which one it is, and I think you're dumb. Okay, we're going to actually start over, and I'm going to copy from the desktop, Node SQLite, VS. There we go. So now it's not going to complain about that. We're going to start over. Completely over. And it really doesn't matter that much. So yeah, people can do whatever they want with that. Okay, clear. Okay. And here we go. As much as I love typing fly deploy every time I want to deploy my app, I'd much rather just have my main branch of my Git repo always be deployable, and anytime I merge anything into the main branch, it just deploys automatically. And I've already got a GitHub repo set up here, so all I need is to have a GitHub And I've already got a GitHub repo here set up, so all I need is a GitHub action that runs the fly deploy command for me, and now I don't have to worry about it anymore. So we're going to make that in a GitHub directory. Under that, we'll have a workflows directory, and under that, we'll have our deploy.yaml. And this will have our config for our action. So we're just going to call it deploy, and we only want this to run on main branch pushes. And then the steps, that's not steps. And then for our job, we'll just have a job called deploy. It runs on Ubuntu, and we have just 2 steps. All we have to do is check out the repo and then run the deploy command with fly. Now, this one's a little bit different. It's not just as simple as run fly deploy. For a couple of reasons. First of all, we need to get fly installed, and we get fly installed using the superfly flyctl actions. So that gets it installed for us, but this specifically will allow us to run a command with specific args. So the args we want to pass to fly is deploy, and we're also going to pass --remote--only. That way we're going to use the fly builder instead of running within the action itself to build the Docker file and everything. Just fly will manage all of that for us. So that's why we're specifying remote only. The final thing is our fly API token needs to be provided because we're not authenticated on fly within the context of this GitHub action. So if anybody could just make a GitHub action and deploy to our app, that would not be a good thing. So we need to have a fly token, and we need to have it accessible for our actions. So let's go to our fly dashboard. We'll go to account and access tokens, and then we'll make one called GitHub action. We'll call create. We'll copy that, and then we'll go to our GitHub repo. We'll go to the settings and over to our secrets and variables under actions. We'll make a new repository secret, and we'll call this our fly. Actually, we need to make sure it's the same, the fly API token. And we'll paste in the secret there, add that secret, and now we're ready to commit this. So we'll git status. We just added the GitHub We just added the GitHub directory, so we'll git add everything, and then commit add new work. And then we'll run git commit add deploy workflow. And now we push. And with that, we can go over to our actions, and in just a moment, we should get a running deploy action. We can speed this up. Let's make that a little faster. And now we can go to that running action. We can look at the deploy, and this should only take a little time here. So if we get to the deploy to production piece, obviously we've been authenticated because it is running, and it verifies our config, it's running our Docker, it's running with our Docker file, and now it's going to push that image up to fly, and then fly will trigger the release, which is happening right now. So we can open up this to look at, don't let that happen. So we can open up the logs and take a look at how our application is doing. There we go. It's shutting down the virtual machine, sending just stop with shutting down the virtual machine. And speed this stuff up. We don't want anybody waiting for any of this. It does take a while in reality, but they don't need to just stare at a video. Come on, what is going on? And now it's starting our instance, pulling up our new instance of our application, and it is listening, and it's already responding to health checks. So let's go to our app, refresh, and everything is running swimmingly. So all we needed to do was create a GitHub repo for our application, create a workflow that has a simple deploy that all it does is check out the repo and runs the deploy command with the Superfly fly control actions. And we created our API token by going to our Fly dashboard and going to Account, Access Tokens, creating a new token, and then going to the settings of our GitHub repo, going to secrets and variables, actions, and then creating a new repository secret that has the same name as the name in our action right here. And then we simply commit that, and then we simply commit that workflow, push it up, and watch it fly. No pun intended. You don't have to add that last bit. The watch it fly is a good way to end that. Okay, great. That worked. Hooray! You don't have to add that. Watch it fly. All right, I just deleted that. You don't have to add that because I think we don't want to confuse anybody. Okay. Simple GitHub deploy action. Okay, great. So now we go from 07 to 08, which is the staging environment. And that one's pretty straightforward. So let's just get that rolling. Go to the Actions tab here. Oh yeah, let's revoke this so that anybody who's watching the live stream right now doesn't mess up my stuff. And we're going to go over here and make a new one. And copy that. We'll come over here and go to our settings to update that secret to the new one that I just made that you all don't see. Okay, so that will work. Go to Actions. Let me delete that. Stick those there. Oh, good glory. Well, I don't think you can see all of that. So we're good. Let me make sure. Oh yeah, that's crazy long. Yeah, good luck guessing the rest of that. No, I think we're fine. It's also not actually all that important. Re-enter my password. Okay, and dashboard. Here we go. We're on the dashboard. Good stuff. Okay. And now they actually made the builder. And I don't think I've explained the builder. I don't think I need to. I think it's fine. Okay. So here we go. A pretty common practice is to have a staging environment that you can run and break things and whatever, and not worry about hurting anybody before you actually deploy to production. And so we're going to enhance this so that we can have a staging environment. The first thing that we need to do is create that staging environment and the volume that's going to run within that staging environment. So I'm first going to go to my flytoml, and we're basically going to create a new app with this same name with a dash staging at the end. So we'll say fly apps create, and this is going to be the name of our app, staging. And now that app has been created, now we'll say fly vol create data region. No, we don't want region. Size. Oh, hold on. Here we go. We're going to start that over. And now we need to have a persistent volume for that app. So we're going to say fly. And now we need to have a persistent volume for that app for our SQLite database. So we're going to say fly. We'll get this. And now we need to create a persistent volume for our SQLite database for that staging environment. So we're going to say fly vol create data app, specify our staging environment app name. Size is 1. Now let me say that size again. Size is 1. And then it's going to ask us to choose the region. We'll choose San Jose. You choose whatever is closest to you. That really doesn't make too much of a difference there. And now we're ready to deploy to this. And now we're ready to deploy to this environment. Yeah. And now we're ready to deploy to this environment. So we need to update our action so that we can deploy to this whenever somebody pushes to the dev branch. Now, as soon as we add this onPush dev, we're automatically going to run this deploy job across on commits to, so delete across, on commits to main or dev. And we don't want to do that because we don't want dev going to production. So we're going to protect that with this deploy production by using an if to say if the GitHub ref is refs head main. So we only want to run this particular step if we're on the main branch. Now we're going to make another one of these and we'll call this deploy staging, and we only want to run this one if we're on the refs head dev. And then we'll update the args so that we are deploying to the staging environment we just made instead of the production environment. Now the trick here is that the flytoml has the production app name, but we don't want to deploy to the production app. We want to deploy to the staging app. So what we can do is copy this. We'll add app, paste our name, staging, and now this will only deploy to that staging environment. However, I don't really like having two things that are hard-coded across two different files, especially when it comes to configuration. I'd much rather read the configuration from the one source of truth and then have it be read by all the other places. Just copy this. And so what I'm going to do is right after we check out the repo, I'm going to paste this other step, the seb rollin toml action step, which will read the name from our flytoml, and then it will expose it as a variable that I can use right here. And that will be exposed under steps.app name. This is the ID that we provided for that step. .outputs.value. And that's the value of the field that we've specified. And with all of that set, we should be able to commit this, deploy to staging, and we can go ahead and push that, but of course we're pushing this to the main branch. So let's test out deploying to the staging environment by going to our app, and we'll add a little hello staging up here. I'm going to change the voiceover on what I just did. And we'll just add parentheses staging here so we can differentiate between our staging. So we can know that we've actually deployed our changes. We'll make a new branch called dev. We'll commit this change, staging, and we'll push that branch to our repo. And now if we come over to our repo and look at our actions that are running, we'll see that we have a staging. We'll see that we have an action running for the staging commit on our dev branch, and we can look at that and watch it go into the staging portion of our workflow. And we can speed this part up. Oh, rats. It didn't work. Oh man, things were going so well. What did I mess up? Refs head dev. What did I mess up? Everything looks fine. Branches, dev. This is the dev branch. Deploy staging. So it's skipped because missed. Heads. Shoot. Okay, we're gonna have to redo all of that. Ah, dang it. Rats. It was so good. It was so good, and now I've got a bunch of commits and stuff. Okay, branch. Get. Okay. Get log. Okay, let's go delete that branch. We'll start this all over again. Okay. Man, and now we've got this staging thing. Delete workflow run. Good. Yes, get rid of that thing forever. Delete that one. Cancel. We're just going to pretend it never existed. Come on, cancel. Thank you. Delete. Go away. And we're all green there, so we're good. Okay, good grief. Let's try this again. Do we need to reference this? Oh, yeah. We do come in here, we do the staging thing, so we'll keep that just there. Oh, I was running ScreenFlow that whole time. Okay, let's try this again. It's really common for teams to want to have a staging environment to run their changes in first and validate everything is working before moving over to the production environment. And so we want to have a branch called dev, and that's where we're going to be deploying and making our rapid changes and deploying to staging. And then when things go into main, we can deploy to production. Now, as soon as I add this dev to our branches config here, anytime we make a commit to dev, we're actually going to deploy to production, which of course is not something that we want at all. And so we're going to add a config to this particular step to say if the github.ref is equal to refs heads main, then we'll proceed with this particular step. And so that way only the main branch commits will end up going to production. And we'll copy this same config for our staging. And so instead of heads main, it'll be heads dev. And then there's one other change that we need to make here, because if we just deploy as usual, then Fly is just going to look up the app in here and it's going to be like, oh, well, bro, I've got the app already. Shoot, I had a thought in the back of my mind and it was distracting me. Shoot. The thought was, oh yeah, I have an environment already and I need to create that environment first. So I got to go delete that. We got to start over. Good grief. And actually, the first take of all of that was actually quite nice, and I wish that I had not deleted that ScreenFlow file because I could have probably used that, but oh well. So fly vol list. Oh, now that's interesting. Fly apps list. That's right. We got it. Oh, shoot. No. Oh. I can't delete that app and create a new one. Shoot. If I delete the app, then I can't create another one of the same name. It just doesn't work. And so now I can't show creating the app because I did it and I deleted the video. Dang it. So options are, I mean, maybe they fixed that. Maybe you can delete it and create it anew. So let's try that first. It's not going to hurt anything. I need to delete it anyway. Fly apps delete. Let's see, destroy. Okay. Should have done this first. Yeah, it's gone. Fly apps create. Oh my gosh, it totally worked. Oh, good. Delete. Destroy. Oh, thank goodness. Thank goodness. Hallelujah. Celebrate. That worked. Oh, good. Okay. So, whew, let's get going. Let's start that over. You used to not be able to do that. Okay. Sorry, that's going to be really confusing to Hayes to open up this video and be like, why did he just say that? Okay. Every commit that goes into main is going to go to production, but what if I wanted to have an environment that's like a special, really close to production-like environment that I can test changes out to before going to production? This is really common for teams, and it's normally called a staging environment, and often they'll just make a dev branch, and everything that goes to the dev branch goes into the staging environment where you can play around with it and test things out. So we're going to make that work. Now, as soon as I created this dev config on our branches, I'm automatically sending things to the production environment because of the way that things are configured down here. I don't want to do that, so we'll make sure to handle that. But before we do, we need to create that staging environment. So let's say fly apps create. And the staging environment, I want to have the same name as my app, just with a dash staging at the end. So we'll say fly apps create that app staging. And then we also need a persistent volume for our staging environment for the SQLite database. So we'll say fly vol create data with the app as our staging environment. And the size is 1. And then we'll choose the region that's closest to me. You choose the region that's closest to you, or whatever region you prefer. And now we're ready to deploy to this environment. So we'll come back here and we'll add a bit of config to this deploy production to make sure that we only deploy the main branch to production. So we'll say if the github.ref is, could you fix my typing there, please? Is refs/heads/main. So now this step will only execute if our ref is refs heads main, which is the main branch. Now we can copy this and make a staging version of this. So if the refs heads is dev, now this one will run. Now it's a little bit tricky here because this deploy command is going to look up our app name inside of the fly toml. And we don't want it to use that one, that's the production one. So we're going to add an app flag here with our staging app name. Now, right here, I get a little bit concerned because I don't like having the configuration duplicated between two different places. Like those two strings are actually really important and close, and they're supposed to be that way. I'd rather have that be encoded in the way that things are written. And so instead of hard coding this, I'm going to use another action step that will, sorry, I gotta swallow and say that again. I'm going to use another action step that will read the app name from our fly toml. This is the sebRollin toml action, which has an ID of app name that I specify. And then we say we want them to read the fly toml and get us the field app, and it will expose that to us. And so instead of hard coding this, we can use this as a variable. And the variable name is going to be steps.appName. That's referencing that ID there. .outputs.value, and that's going to get the value of the app property in the fly toml. And now I don't have to duplicate that app name, and I can use this in other apps that I deploy on fly as well, which is quite nice. With all of that set up, we can now say git commit add staging environment. We'll push that, and again, we're pushing to main, so this is going to actually deploy to our production environment, but we can look at that action as it comes in and ensure that indeed only the production step is the one that gets run here, and the staging step gets skipped. So we'll just let that run. And here we can see the deploy staging step got skipped, but the deploy production step is running just as we would expect. Now let's just test this out really quick. We'll say demo app staging in parentheses, and then we'll make a branch called dev. We'll git commit staging and push that dev branch to GitHub. We'll look at our actions again, and we see that staging commit in dev has kicked off a new workflow run, and this one hopefully will just run the staging and will not run the production step, so that we deploy to staging instead of production. And indeed it is running the staging step. And now it's releasing our v2. So we can look at our logs here, pop that open, on our brand new staging environment, which is currently setting up the volume data. And it's executed our migrations because it just barely created this new database. And now we're all set. It's already starting to give us logs for those health checks. So we can go to overview and look at this host name, open that up, and we've got our demo app staging and we've got our demo app production. So everything is looking exactly as it should. And let me try that voiceover again. And I want to, could you do some video magic so you don't see me bump up and everything? I just want it to look exactly the same. So maybe when I tab over here, just make it be right here. So skip all the stuff from the time I was here to when I opened up the tab, and I'll go over here. So right now. And our demo app staging is working just fine. It's doing exactly what it should. It looks, no, I say that all over again. And our demo app is looking, and our staging environment is looking exactly the way it should. It has our changes, and our production app does not have those changes, so we can safely experiment in the staging environment without worrying about the production environment getting affected. In review, to make this work, we updated our, let me say that again. In review, to make this work, we first created the staging environment with fly apps create, and then we created the persistent volume with fly vol. And then we created the persistent volume with fly vol command. Let me say that. And then we created the persistent volume. Here, I wonder if I can actually show some of that stuff in here. Yeah, okay. In review, what we did to make this work is we ran the fly apps create command to create our staging environment. Then we ran fly vol create to create the persistent volume for our staging environment. Then we updated our deploy script. Let me say that again. Then we updated our deploy YAML so that we would only deploy to production if we're on the main branch, and we had a staging step and we added a staging step that deploys if we're on the dev branch. And then we also read the app name from the fly toml, so we could use that as part of the deploy command of our staging step. And then we pushed our changes, made some changes specifically for our dev branch, and pushed the dev branch. And that's how you get a staging environment. And that's how you get a staging environment automatically deployed with fly. All right. Whew. There's going to be a little bit of editing there. Sorry. I just was struggling figuring out how to say what I wanted to say. Okay, staging environment. And we'll never use it again. Oh, whoops. All right, so what comes next? After 8, it's 9. GitHub PRs. Another thing that teams want to be able to do is make pull requests and see some of the build. Let's try that again. Another thing that teams like to be able to do is create pull requests and run the build and test and validation, that sort of thing. And with our config right now, we don't run anything during the, you know what, do I really care about this? I mean, you can make other workflow files and stuff. No, we're going to care about this. We're going to stick it all in the same thing. I don't know. Some people probably will disagree. Not that I care about whether people disagree, but yeah, maybe it should just be another file, and I should just skip this altogether. Yeah. I think so. Yep. Yeah, we're not going to do this. We are not going to do this at all. So coming back to this, this will be 11. Here, let's get rid of this first. The PRs thing is gone. This no longer has any of this stuff. So this goes away. And the build goes away. Whoops. We also need to remove this. So pull request goes away, build goes away, and needs build. You know what? There's an easier way to do this, just to make sure that I've got the right stuff. And that's to go here, grab this, and paste that. There we go. All right. And then in here, get rid of that. Get rid of our build. Yep. Just make another step if you want to do that. And I don't have to teach you how to do that. Okay, so then this is now 9. This is 8. Whoops. No, this is 10. There we go. Not 19, 10. And this is 11. And now this is 11. Remove GitHub PRs step. Okay. Great. That's good. So now we're finally doing multi-region stuff. This will be really exciting. So we update the Docker file. Here, you all can see this. The Docker file in a couple spots. We add the lightfs config, and that's it. Okay, cool. I can do that. Okay, cool. We've got our staging environment, yada, yada, yada. Okay. Okay, so in this one, we're going to need our Docker file, and we're going to need a new file, but we won't need anything else, which is kind of cool. That's the idea. Okay, flylight fs. Not recommended for production use yet. Well, I'll tell you what. This site is pretty sick. And it's running lightfs. So what are you going to do? Yeah, it's pretty sweet. Okay. Introducing lightfs. Okay, there we go. Oops, stick that there. Do they put that on every page? Oh man, fine. Okay. Do I need CA certificates? Maybe I don't. I think I might not need CA certificates. I wish that this deployed so I could test that out. That's weird. Oh, whoops. That is good to know. Okay. Yeah, I don't think I need CA certificates. I think it doesn't say anything in here about that. So we're not going to add the CA certificates. We're just going to add Fuse. And then we create the lightfs environment variable right here. Update that. Maybe we config it first. Yeah, let's do the config first. So we're going to make the config. LightFS uses a tool called Fuse to simulate a virtual file system. Okay, cool. I think I can manage this. And yeah, that did not work again, which is really annoying. I wish I knew why. Here we go. One of the primary, value proposition. One of the primary value propositions to Fly.io is that you can deploy app servers close to your users, run your full stack apps and databases all over the world, no ops required. So far, we're only running in a single region, and it would be really cool to deploy our apps and our data as close to users as possible. Now, there is a fair bit of complexity in doing this, and so if you really don't need to have that deployed to the edge, let me say that differently. I'll start all over. Did I start recording? Yeah, I did. Let's do that over. One of the primary value propositions of Fly.io is its ability to deploy app servers close to your users. Its tagline is run full stack apps and databases all over the world, no ops required. It's got regions all over the place, and we've only deployed it. Let me say that again. It's got regions all over the place, and we've only deployed to a single region. You might want to use my face for this part, so I'm going to get a perfect take just once. One of Fly's primary value propositions is the fact that you can deploy app servers close to your users. Its tagline is run your full stack apps and databases all over the world, no ops required. There are regions all over the world that you can deploy your Fly app to, and so far we've only deployed our app to a single region. So I think it would be cool if we deployed to the edge. Now, there is a fair bit of complexity added when you start deploying your app and your data all over the world, but I think that it's worth it in a lot of situations where performance is a really important key aspect of the application that you're building. So we're going to go ahead and set that up for ourselves. Okay, that was good. I don't know if you still want to use my face, but I needed to take that break. Okay. Fly has support for Postgres clusters and Redis managed for, let me try that all again. I'm sorry, the scroll is going to be a big mess. You know what? I'm going to re-record it. We're going to do it all perfect. Here we go. One of the primary value propositions of Fly.io is its ability to deploy app servers close to your users. Its tagline is run your full stack apps and databases all over the world, no ops required. So far, we've only deployed to a single region, but with Fly, you can deploy to regions all over the world and get a really nice performance benefit regardless of where your users are. Fly has built-in support for Postgres clusters as well as Redis clusters, and it's really awesome. And Fly has also got support for LightFS, which is the ability to, for distributed SQLite. That's what it has through its project LightFS. Yeah, okay, we're almost there. It's going to be fine. All right. One of the primary value propositions to Fly.io is its ability to deploy app servers close to your users, and not just like serverless functions and whatever. I should think about that before I try to speak it. Because the thing is, like, people are like, yeah, I got CDNs all over the place. But no, this is very different. These are long-running servers, so you can do way more than you could do with your edge functions and stuff. It's actually like full databases and stuff. Okay, here we go. One of the primary benefits to using Fly.io is its ability to deploy app servers close to your users. Their tagline is to run your full stack apps and databases all over the world, no ops required. So far, we've only deployed our app to a single region, but we could deploy our app to many regions all over the world. We could take advantage of Fly's ability to host our node server, but also Postgres clusters or Redis clusters all over the world managed for us by Fly. And Fly also has support for distributed SQLite. Lucky for us, because we happen to be using SQLite, and it does this through its project called LiteFS. And we're going to set up LiteFS. Oh! Okay, you can switch from my face right here because I was talking too much anyway. So that intro was fine. Let's leave the intro and we'll just go right into let's get that set up. So let's get that. You know what? I feel like it was really close. We're going to get this properly. One of the primary benefits to using Fly.io is its ability to deploy app servers close to your users. Their tagline is run your full stack apps and databases all over the world, no ops required. So far, we've only deployed our app to a single region, but we can deploy our app to many regions all over the world. And that's actually really straightforward. If all you're doing is a node server, you can just deploy that all over the place. But if you're also trying to deploy your data, that can be really challenging. And Fly has built-in support for Postgres clusters with read replicas all over the world. The same thing for Redis. And why do you have to pause after saying and? Because you know what you're about to say, Kent. And distributed SQLite with LiteFS. All right. One of Fly's primary benefits is the ability to deploy app servers close to your users. Their tagline is run your full stack apps and databases all over the world, no ops required. You know what? If you're going to be just looking at my face, then I shouldn't be looking at the screen. I should be looking at the camera, and we're not. I don't know what we should do with this video. You know what? I think it should just be my face. So I'm going to look right at the camera. I'm not going to look at anything else. If I'm going through all this trouble trying to make it perfect, I may as well take advantage of that. One of the primary benefits to using Fly.io is their ability to deploy your servers and your data as close to the users as possible with their many regions all over the world. Now, deploying a node server in many regions all over the world, that's actually not all that difficult. The real challenge is deploying your data along with your node application close to the users all over the world. And Fly has built-in support for Postgres and Redis with read replicas all over the world. Fly also has support for distributed SQLite, which is really, really cool. They use this tool called LiteFS. They've built this tool. They don't use it. They made it. It's theirs. Ah, we were so close. I also got my 10,000 steps, so that's exciting. And I just realized, oh good, I did get last hour, so that's good. I think it's all this hand waving that I've been doing. So yeah. Good. Okay, we're going to start over. We are close. We're very close. Also, I got a reply on why we shouldn't just do the simpler way that I just recorded videos for. Okay, here we go. We're going to get it right this time. One of the primary benefits to using Fly.io is its ability to deploy our app servers close to our users, but not just our app servers, our data as well. Deploying long-running node servers in multiple regions all over the world is actually not a huge challenge. The big challenge is what do you do with the data? And if you're deploying your app server to the edge, that's great, but if your data is still in a central location, that is still going to be a bottleneck for your users, regardless of how close you're deploying your app server to them. And so Fly has built-in support for distributed Postgres and Redis and even SQLite through their project LiteFS. So we're going to configure LiteFS for this project because we're only deploying to a single region currently. And once we have that all set up, then we can start deploying to multiple regions and have both our node server and our data close to our users, giving them the best performance we possibly can. So let's get that configured. Oh, good. Okay, that was a great intro. We're going to use that intro and we can cut over to the editor probably. Yep, just right here. So you could probably cut to this and say, let's get that configured. Actually, let's cut to this. So yeah. So let's get that configured. Here we go. So first of all, Fly depends on this package called Fuse, which creates a virtual file system. And so what LiteFS, no, it's not Fly. Let me start that over. So first of all, LiteFS depends on this package called Fuse, which acts as a virtual file system. And so what we're going to do is we actually move our SQLite database into this virtual file system, and that's where our application is going to access it. And then Fuse and LiteFS will actually write the actual database to a separate directory altogether. And so LiteFS can intercept all of the writes and reads and everything that happen in the virtual file system and propagate it to the read replicas all over the world. So we need to add Fuse to our application. So let's come to our Docker file and we'll just add that as one of the things that we apt-get for our Docker file. The next thing that it wants us to do is to copy the binary for LiteFS. And so we're going to bring that over right before we start with our script. Let me say that again. Right before we run our start script. So we'll put it right here. Now we have the LiteFS binary in our Docker. Now we have the LiteFS binary in our Docker file as well. The next thing we need to do is configure LiteFS, and we need to make sure that we have this LiteFS YAML file inside of our etc/LiteFS. Inside of our etc/LiteFS.yaml. So what I'm going to do is copy this, and we'll add another add command here to add litefs.yaml to etc/LiteFS YAML. So let's make that litefs YAML file, and this is where we're going to configure LiteFS. The first bit of configuration is for Fuse, and then the second is for data. So let's copy both of those over and talk about those for a second. So Fuse is the thing that's responsible for our virtual file system, and it's saying, hey, where do you want me to create the virtual file system? We can have this be anywhere that we want to, but one thing I want to make sure of is that we're not duplicating configuration in two places. And so our application is going to need to access our data, this database URL, will need to reference something inside, no, don't let that happen, something inside the LiteFS directory. And so what we're going to do instead, let me try that differently. So instead of accessing our data from /data, which is our persistent volume, we want to access it from LiteFS. from lightfs/SQLiteDB. But again, I really don't like having configuration that should be the same spread across multiple files. So what we're going to do instead is I'm going to make another environment variable called lightfs. Let me try that again. So we're going to make another environment variable called lightfs_dir and make that point to lightfs. And then we'll reference that inside of the database URL and inside of our lightfs config. And then our data is where the actual data should be stored. And we have a mounted volume, which we configured in our fly toml right here, to have a volume at /data. So that's where we're going to put it. We'll put it in /data/light. So we'll configure this to /data/lightfs. So this is where the actual database will exist. I just realized we don't have line numbers in my editor. That's kind of unfortunate. I think we should have line numbers. I think it's probably okay, but that's annoying. The last bit of config that we need is the lease configuration. And we're going to go with the most simple basic version of this to start, and then we can add. And we're going to go with the most simple basic. So we're going to go with the most simple basic version of this to start, and then we can make it better later once we have lightfs actually running on our server. So we're going to specify that the lease should be a static lease and that this. So we're let me describe this a little bit better. Yeah, let's come back here. I hope you can figure out like a good place for my voiceover to go with the scrolling position and stuff like that. Sorry. The last bit of our configuration for now is the lease configuration. So because we have multiple let me say that again. The last bit of configuration for lightfs is the lease configuration. Now this is really important because if you have multiple regions all over the world, you can only write to one of those, and then the rest of those is going to be a. Let me say that again. Now the last bit of our configuration is the lease configuration. This is very important because in a read replica type of architecture, you can only have one region that's responsible for doing all of the writes, and all of the other regions will just be read replicas. Yeah. The last bit of the configuration for lightfs is the lease configuration. Now this is really important because in a distributed architecture, there are many distributed architectures, but in this one, yeah. The last bit of our lightfs configuration is the lease configuration. This one's really important because it describes how a primary region is selected. In a distributed architecture like this one, you can only have one region that can write to the database, and the rest of the regions are simply read replicas. So if those regions try to write to the database, it's not going to work, and you could wind up with really gnarly consistency issues if it did. So the rest of the regions can only write. Only one region can be the primary region that can write. And when that region writes to the database, then all of the others get the updates to the database automatically. So we have to specify which of all of our regions can be the primary region so that we don't have multiple versions of our application or multiple instances of our application all over the world trying to become the primary and start writing to their databases and getting out of sync with each other. So the lease configuration is responsible for ensuring that the right region gets to be the primary. To get us started, we're going to go with a static lease configuration just to make sure that we have lightfs. So close. You know what? We can cut from my face and we can actually do this. To get us started, we're going to go with a static lease configuration just so that we can make sure that we have lightfs running successfully in our application, and then we can go to something a little bit more complex later. So with all of this set up, the last thing that we need to do is make sure that we run our application under LightFS. And the reason that we do this is to make sure that LightFS has the virtual file system up and ready to go before our application starts trying to access that data. And so what this means is we change our command from simply command npm start to command lightfs mount, and then we pass it this the start script npm start. Man, Copilot was like having a field day on that thing. And with that all configured, we can deploy this and run our app within LightFS. So let's do that now. Well, should I deploy it locally? Or should I push it to the through the GitHub action? Let's do the GitHub action. So let's commit this with add lightfs. And I'm committing to the main branch. You typically, in a running application, you probably want to push this to your staging environment first, but we're going to live on the edge here a little bit. I just realized that I didn't, shoot. I didn't add the lightfs file. Oops. Okay, come on. Okay, good. All cleaned up. Man, it's easy to teach you all about React. This stuff is hard. Okay. So let's go ahead and add everything, git commit, add lightfs, and git push. And with that pushed, we should have our action running and get that deployed to our production environment. And I'll just add that I'm deploying straight to production just to make things easier here, but if you had a running application that you were adding this to, of course you'd probably want to use your staging environment, get everything working there first before going to production. So let's take a look at this deploy step. Looks like it's running just fine. And we can open up our logs as well to make sure that this deploys okay. And there will be a couple of interesting things in our logs here, so I want to keep an eye on this. And then we're going to just wait and let this happen. For stuff like this, you don't really probably need to speed it up, just like cut to when it's interesting again. Okay, here we go. All right, so now it's pointing our new container that has the lightfs binary in it. And the first thing that's going to happen right here is you'll see the config file was read from lightfs. the LightFS version is printed out here. We're using a static primary, so we specified we only have one static primary and this is it. And then the lease is acquired because it was static. LightFS was mounted to the directory we specified. The HTTP server for LightFS is listening, so it's ready to accept other registrants who want to be read replicas. Then we're waiting to connect to the cluster. It was connected and then started the sub process, which we specified to be npm start. And then our application was able to run, and Prisma has been started up. Prisma found one migration, and the reason for this is because we created a new database file. So if you wanted to migrate over to this architecture from an existing database, then you'd want to make sure you did a backup of your existing database and then imported that old data into LightFS. And LightFS has an import command that you can use and get all that data imported in just a few seconds. But because we didn't do things that way, it applied these migrations, and now our app is up and running, and it's all running within LightFS. So if I refresh the page, we're going to go back to 0 because we reset our database doing this, and I can increment and decrement, and we're ready to go multi-region because we have LightFS sitting between our application and our database. Okay, let me see if I can, I think I need to review. In review, the way that we made this work is we updated our Docker file to first include Fuse, so that LightFS had Fuse to act as the virtual file system. We added an environment variable called lightfs_dir to specify the directory we wanted that virtual file system to be inside. We updated our database URL to be inside of that virtual file system. We added the LightFS binary and added the LightFS config, and updated our command to run npm start under the lightfs mount command. Our lightfs config specifies the Fuse directory to be that lightfs_dir environment variable that we set in our Docker file. We updated the data dir to be in /data/lightfs, so that's where our SQLite database should live. And then we specified the lease for determining who the primary region should be to be type static and have the candidate just be set to true. And we'll update this when we start adding multiple regions. And that's how you get your Node application running on, and that's how you get started with LightFS. There we go. Okay. Yeah, that was pretty good. Fair bit of editing. Sorry, Hayes. Okay. 10 LightFS init LightFS. There we go. I am super hungry, but I need to finish this. I just got to. Okay, so now there's quite a bit of stuff we got to do. This one's going to be tough. Okay, so let's think about these the different things that are happening in here. So for one, we need to where's my, do I have notes in here? All right, so enable console, configure console. That's that. Deploy migrations if primary. Ensure primary on non-get requests. And so we also need to determine primary and send replay request. Okay, and that's here, and that's here. Yeah. Okay, so we're going to split this into a couple videos, I think. Probably could enable console first. Yeah, that can be a separate thing, I think. So we enable console, specify console, update the fly, advertise URL, the console URL, and the key. Okay, so we'll do that first. Okay, yep. Yeah, okay. Jeez. Yeah, it's not documented at all. Okay, I think I'm ready to do this. One drawback of the lease config that we specified with static is that if the primary goes down for any reason, hold on a second. If the primary goes down, then the entire application goes down. Using console leasing, another region could take over, or another instance could take over as the primary, and your application will continue to function. Okay. One of the drawbacks of the static, let me try that again. One of the drawbacks of the static lease configuration. One of the drawbacks of the static lease configuration is that if the primary node goes down, then all of the other instances go down with it. If we switch that to a console type, then another region could take over as the primary if the primary region goes down. So we're going to switch our configuration from static to console. It is a little bit more involved, but we're going to give that a shot. So let's go over to the configuration reference that is specified here, and we can look at console leasing. And there are a couple of pieces that we need to consider. So first of all, the advertise URL needs to be specified. So let's go up here, add advertising URL, and this one is a little bit let me try that again. And this is a little bit involved, but basically we get the host name environment variable, .vm, .fly app name, another environment variable, .internal port 2022. Try that again. Port 20202. This is an internal URL that's only accessible from within the Fly network and allows different virtual machines to communicate with one another. We also, of course, want to change from static to console. And I'm going to change the candidate from true to fly region equals SJC. That basically means that as long as the region is within San Jose for me, no, let's say that again. That basically means that as long as the fly you know what? No. That basically means that as long as the fly, should I do that differently? Should we just leave it as true? And then change it when we decide to go to multiple regions. You know, I'm not happy with how I've been explaining this or doing this, so let's start this over. One of the drawbacks of the static lease configuration that we have in our... Hold on a second. There we go. Let me try that again. One of the drawbacks of the static lease configuration that we've set up is that if the primary node goes down, then all of the other instances of our application go down with it. If we switch this to the console type, then a primary node goes down and another node can take its place. This is a lot nicer and more resilient, although it is a little bit more involved. So let's go ahead and configure ourselves for console leasing, because we want to get that nice reliability that we can get from console leasing. The first thing that we need to do when we want to switch to console leasing is actually enable this under the experimental configuration in Fly. So we simply say enable _ console is true, and now we have a console service available for our and now we have a console service available for our node application. And now we have the console service available for our application. So now we can update our liatfs config to switch from a type static to a type console. Let me try that again. Ah, man, it doesn't have an E at the end. There we go. And with that, we have to specify an advertise URL. So this is the URL that we want to let. So this is the URL that we have to specify. Hold on a second. There's a repo. I was looking at it a second ago. Shoot, there's another one. Here we go. Okay. I believe you should be able to cut that, no problem. And now we specify the And now we specify the advertise without a Z, good grief. And now we need to specify the advertise URL. And this is the URL that we use to communicate between different virtual machines in our cluster of Node applications. So this is HTTP host name, so whatever the host name of the virtual machine is, .vm, .fly app name, so that is specific to our app name, .internal : 2022. And this is an internal URL that is accessible only within our Fly network. And this is how our different VMs are going to be able to communicate with each other so they know who is the primary region. Or so they register themselves. So they can register themselves with the primary region. There we go. Finally, we add our console configuration. And this is just going to have URL set to an environment variable that LightFS offers us, and that is fly, or no. And this is just going to have a URL, and this is going to have a URL that is simply the environment variable that Fly is going to give us. It's called the Fly console URL. We get that environment variable as soon as we enable the Fly experimental option here in our Fly TOML. And then secondly, a key which uniquely identifies our specific Fly instance. Let me say that again. Which uniquely identifies our specific console service deployment. Which uniquely identifies our specific console deployment within the Fly network. So we're going to call this lightfs/fly app name so that we can keep it unique across all of Fly. And with all of those changes, now we can git commit, enable console, and then git push. And this will get deployed, and now we'll be running within the console. And now LightFS will be operating from. And now LightFS will be operating with the console lease strategy, which is a little bit more resilient. And now LightFS will be operating within the console strategy for leasing. No. And now LightFS will be operating from when. And now LightFS will be operating with the console lease strategy, which is more resilient. Okay. I think I'll do it in review. In review, to make this work, we first have to update our Fly TOML under the experimental flag to say enable console true. And then we go to the lease config in our LightFS config, set the type to console, the advertise URL to the unique URL for our Fly instance, and then console should have a URL specified to the environment variable that's made available to us after we enable console. And key should be something that's unique to identify the specific console service. Okay. You've got to be joking. I hate this so much. Ugh. Recording error. Why couldn't you have told me that earlier? Wouldn't it be like sensible to check every now and then to see whether there's a recording error and let the recorder know that there's a recording error? That just seems reasonable to me. Am I being unreasonable? Good gosh. That is so frustrating. That really hasn't ever happened before. Until I started recording this course. So I'm very confused by this. Maybe this is why I need the CA certificate. So let's try that. This might actually be an okay thing that it happened. Is that what it is? CA certificates with, well, we'll trust Copilot. we're going to force push and delete all these workflows and stuff after. But this will be good. Now I know why I needed that in my Docker file. Okay. Seriously, people, React is so much easier to teach than this. This is crazy harder to teach. Oh, man. I actually really look forward to teaching stuff that doesn't rely on services. Services and config are not fun. Not fun even a little. I'm pretty sure this is going to work. So this works out for me because I didn't know what that certs thing was all about anyway. Okay, so let's come down here. Yeah. Yeah, I'm pretty sure this is going to work. Okay. Okay, good, that worked. Great. So now we have to undo all of that. So we get rid of CA certs. We undo all this stuff. And static. We remove that. Actually, you know what? There we go. Looks beautiful. It's nice that we get to here, let's rerun that. Get that deployed again. Yeah, it's really nice to be able to delete those workflow runs and force push so that it's not so bad. The only thing that you don't get is the deployed versions. Yeah, that would be a lot harder to get that to line up perfectly. But at least we can get this. Okay, so we've got our release configuration, and I'm going to add lines. We're bringing the line numbers back, baby. It might be a little like, whoa, whoa, where'd those line numbers come from for people? But, you know, what do you do? Okay, cool. Now we have this deployed. It is not running under console. So yeah, we're good. Okay, geez. Probably should drink. I just really want to finish this so bad. All right. So we'll just have our actions right there. And we'll try this again. One of the drawbacks of the static lease configuration that we have is that if the primary instance goes down, then all of the other instances will go down as well. But there's another configuration we could use that instead will switch the primary instance to a different one if the primary falls over. So it's a little bit more resilient to that kind of a problem, and I think I want to try that instead. And this is called the console type. So if you go to the configuration reference here, you can learn a little bit more about console leasing. And the first thing that we need to do to enable console leasing on Fly is to go to our Fly TOML under experimental and update this to say enable underscore console is true. With that, it gives us a couple of things, including the console service running for us, so we can change our lease type to be console instead of static. Then we also need to specify an advertise URL. You gotta spell that right. An advertise. You know what? I'm just gonna copy and paste the rest of this, and we're just gonna do that. And then we also need a couple other pieces of configuration. The advertise URL is a unique URL for a particular instance to advertise that it is to listen for registrations or to communicate between virtual machines. The first of these, so let me try that all again. So we also need a couple other pieces of configuration. The first of these is the advertise URL. This is a unique URL that identifies this particular instance so that our instances can communicate with each other. And then we have this console configuration where we specify the URL to be an environment variable that Fly creates for us once we enable console. And then this key is unique across all console instances so that console can identify the different console instances throughout. I don't know what it's for really. So I'll just say, I don't really, yeah. And last, we specify a key which needs to be unique across all of Fly. So we just set it to lightfs/flyappname to make sure it is unique. And then finally, console needs access to CA certificates. So we'll add that to our Docker file. And with those changes, we can git add everything, git commit with switch to console and git push. And now our application can be a little bit more resilient in case the primary node falls over. And we did this first by enabling console under experimental in our Fly TOML. And then our lightfs configuration changed the type to console from static and added the advertise URL and the console configuration here. And then our Docker file added CA certificates so console could use that. Woo! Okay. That's good. We don't need to actually watch it successfully deploy and everything. Actually, you know what? We should. Yeah, because there's like different logs and stuff. So with that all set up, let's go ahead and take a look at our logs. We see that the virtual machine is now being shut down, and we're starting up the new one that has the console configuration. And there will be a couple of changes to the logs here that I want to look at. So the first bit here is that the config is still red, the console lightfs, so don't say console. Lightfs prints out its version. We're using console to determine the primary. We initialize console. And then down here, the primary lease is acquired, and it advertises the fact that it's the primary on this URL that we configured. It's been connected to the cluster, and it's ready to start our process. And so now our app is running. Let me say that again. And so now our app is running. With lightfs using the console strategy. Not strategy. Using the console lease strategy. There we go. All right. Okay. Setup console. Okay, and I actually want to make that an official change here. So this is now going to be 12. This will be 11. This will be 10 lightfs, or we'll call this console. This we will go to. Oh, hold on a second. Oh, did multi-region switch it to console? Yes, it did. Okay, so delete that, copy multi-region, and this will be 10 console. And why is this crossed out? Okay, we've got CA certificates, we've got console config right here. This candidate is true. And our app does not have fly in it. Our index should be just like the previous, unchanged. And our start should also be unchanged. Okay, so if I do this, then the only thing that changed is console. Oh yeah, and we need to update the Docker file here to not use CA certificates before we bring in console. It's nice to know when we need that CA certificates. Okay, cool. So now we add CA certificates, we enable console, and we update the config. That's great. And then from 10 to 11, we add fly to determine the instance and ensure primary, and update the candidate. And yeah, I'm pretty sure that we're going to have to do all of this stuff in a single change that we commit. Or we just make the fly file. I think we should just do all of this, almost all of this in a single thing. So I think we'll probably split it up a little bit, but that's as far as the repo. We'll split those up. Oh, right. And our deploy workflow, now we're looking at 12 transactional consistency. Add console step. Okay. Cool. So looking at 10 to multi-region. We need need to have our start script up. Okay, so you hear that thump? Yeah, stuff's going on, I guess. Yep, somebody just used the bathroom. Okay. There's just a ton of stuff to do, so I think we're going to start with one video that does how to determine the primary instance with LightFS. Yep. Because we want to go multi-region and only one of the instances of our application can actually write to its database, we need to have a mechanism for determining which is the primary instance and therefore can write to its database so that the other ones don't attempt to do so. So we're going to have this flyts file that's going to be responsible for managing all of the stuff that's specific to Fly. We're going to export a function. We're going to export a function called getInstanceInfo. This will just get information about the currently running instance. So the instances are identified by their host name. So we'll get the current instance from os.hostname. We get os from the os. We get os from the os module, and we get os from the os module in Node. And then we're going to let the primary instance be unknown, technically, until we try to read a special file. Let's see if we can get Copilot to shut up about that for a second. Copilot's actually, I'm totally cool with Copilot being a part of my videos, but sometimes it can be kind of annoying. Let me back this up. We're going to try to read a special file that LightFS creates for us when we're running in production. So, and that file is located inside of our LightFS directory, which we have set an environment variable for. So LightFS dir, and then in our LightFS config, we've specified fuse to create its virtual directory inside that LightFS dir. So we can reference LightFS dir from process-env, and let's also add an invariant right here that simply says LightFS dir. LightFS dir is not defined, so it makes sure that that thing is defined. If it's not, then we'll get a nice error message explaining why things are not the way they should be. Then we'll say primary instance is going to be equal to reading a special file inside of that directory. So we are going to await fs, and let's bring in fs, import fs from fs, and promises .read file, and the file that we want to read is inside of that LightFS directory. We're going to want to combine some paths, so we'll say path from that node module there, and we'll say path.join LightFS, and it's not primary instance Copilot, it is .primary. And inside of this file, which is UTF-8 encoded, it will have a string that identifies the host name of the primary instance. So we can say primary instance equals primary instance.trim, just to make sure we don't have any extra spaces or anything before or after. And if there's a failure in reading that file, then the primary instance will simply be the current instance. So the primary instance will not actually have this file at all. So only read replicas will get this file. And so if there's a problem in reading this, then we can just assume that we are the primary instance. Now we can return the current instance, the primary instance, and just as a little helper, the current is primary is the current instance equals the primary instance. So in review, to identify the primary instance, we're going to reference the dir that we configured for fuse, which we set to this lightfs dir in our Docker file to be at /lightfs. We reference that environment variable. We double check that it is actually defined. And then we assign the primary instance to the contents of the file that's at lightfs/.primary. Let me say that again. lightfs dir /primary. To the contents of the file, to the contents of the .primary file inside of the lightfs dir. And if there's an error at any time, we'll just assume that our current instance, which is the os.hostname, is the primary instance, and then we return an object that has that instance info. Okay, there we go. That's not too bad. So this is 012 or 12. Determine primary instance. Okay, cool. So let's do a git diff. Let's see if I can make this work. Counter app, desktop, counter app, and step 11. Oh man, it's giving me stuff in the git directory. Oh, good grief. Okay, if I go down to the bottom, then I can see differences. Oh, that's the build directory, I think. Uh-oh. Oh, shoot. Ah, shoot. Well, it did work. We're just going to pretend that never happened. Dang it. Ah, gosh, dang it. That slash is bad. It's like 3 videos we had that. Ah, crap. Oh. Okay, so the question is, does it just work and is it fine? So we're going to fly SSH console. And now we're going to cd into lightfs. Yeah, there it is. So it's fine. It's not great, but it doesn't break and it goes where it's supposed to. So we're gonna just be happy with that. Yeah, see, it's just lightfs. Huh, very interesting. So it does technically work. That's so weird. That's nuts. I did not know you could have extra slashes. Funny that. Okay, whatever. That's fine. Okay, so I'm just looking at the diff now. Got a couple things that don't actually matter. Oh, yeah, we don't care about the error. We'll just get rid of that. That doesn't matter. Then we have ensure primary. There. And then our start script. So let's do the start script next, and then we'll do ensure primary. So that'll be 2 more videos. When our application is starting up, one of the things that it does at the start is deploy any migrations. This is definitely something that we want to have happen, but we can't do that on non-primary instances because they cannot write to their database. Only the primary can and needs to write to the database, and all of the read replicas will just get those updates that the primary is doing. So not only is it not necessary, you'll also get an error if you try to run Prisma migrations on non-primary instances. So what we're going to do is grab the built version of our file here, because this is when this is going to run. It's just in production right before we're starting our app. And we're going to get the exported get instance info. So get instance info is going to come from a require of build fly. It didn't autocomplete, so I'm just wondering if I got something wrong, but I think that's right. And then inside of here, we're going to get all that instance info. And the things we get are the current instance, the current is primary, and the primary instance. From there, we can say if the current is primary, then we can exec this. Otherwise, we can simply log out something like console log primary instance. Oh, let's try this again. We can simply do something like console.log. Ah, man, I'm having a hard time typing. We can simply do something like console log instance current instance is not the primary. Skipping migrations. And let's add a console log here as well. Instance is the primary. We don't need that. That's pretty obvious. And running migrations. And that's going to make sure that we don't run migrations on the non-primary instance. Okay, that's it. That was easy. I mean, it was not easy to record, but it's easy to do. There's not a lot to it. Okay, 13 migrations, non-primary migrations. All right. Cool. So now what you got for me on this diff? Yeah, I know the logs are a little different. That's fine. I don't care. Okay, so the last thing is the ensure primary. And then we'll actually do the multi-region deployment. Now, obviously, most applications are actually going to want to write to the database. So the question might be, how do I avoid writing to the database if I have let me say that again. Now, most applications actually need to write to the database even if they're the non-primary region, and that is the case for us. If we look at our post request right here, we have this Prism account update right here. How do I make sure that the non-primary region doesn't execute this code without making things super complicated for me? Well, in my application, I pretty much just make it so post requests redirect over to the primary region so that only the GET requests, which are reading from the database instead of writing, will go to my multiple regions all over the world. In a lot of applications, reads are done a lot more than writes, and so that makes a lot of sense for those types of applications. So what we're going to do is we just need to make sure that this post request doesn't ever end up in a non-primary instance. Now, Fly doesn't have any mechanism for doing this automatically for us, and so we do have to do a little bit of application code. But typically in a framework scenario, you can just say, hey, for all post requests, I want you to execute this code. Fly has this special mechanism for us to say, hey, Fly, I'm in instance A, but I want you to instead send this request to instance B. And these are called Fly replay requests. So let me say that again. And these are called Fly replay responses. So in our fly.ts file, we're going to add another export for a function called ensure primary. And this is going to take a response, which is an HTTP server response. Let's import that type up here. Import type HTTP from HTTP. Now, of course, this is going to be different depending on the environment that you're running, the frameworks that you're using, that sort of thing. But we're just doing straight up nodes. So we're going to get that response. We're going to get that response object. We're going to get our primary instance info. So await get instance info. Current is primary. And let me say that again. Current instance, current is primary, and primary instance. And then we can say if the current is primary, then we'll just return. We don't need to do anything like that. We'll just return null. Nothing needs to happen in this case. Otherwise, let's console log replaying from the current instance, current to primary instance, primary. And to do the actual replay, we have our res. We use the response write head. We'll do a 409. We'll do a 409 status code. This actually never makes it to the browser because it will be intercepted by Fly anyway, but I just liked using the 409 status code for this. Then we'll say Fly replay header. Then we'll specify a Fly replay header, and the value of that is instance equals primary instance. And that's what communicates to Fly that we want to take the same request that came in to the current instance and send it to the instance that we are specifying. And then we'll return res.end. And then in our index here, we're going to await ensure primary. We'll get the result from that, and if there is a result, then we'll return that instead. And let's send the response object along to that ensure primary. Again, this may feel a little invasive, but in most scenarios, you can pretty much just say at the front of all of the requests that are coming into your application, you put some simple code like this, and then you don't have to really worry about it anywhere else in the app. However, there are some situations where you do make writes to the database in a GET request, and those will need to be handled in a similar fashion. I'm going to just add one thing. No, that's it. We'll just do in review. In review, what we did here was made an ensure primary function that accepts the response object, and we get the current instance info. If we are the primary, we don't need to worry about anything. We can exit early. If we're not, we just console log something useful and send a response back that has a fly replay header specifying the instance that we want to replay a fly replay header that specifies the instance we want to replay this request onto, and fly will intercept this response and replay the same request to that instance, and which will be the primary instance, which can successfully handle the post request. Okay. Oh my gosh, another recording error? You've got to be joking. What is this? Okay, ScreenFlow, do you have an update or something? Holy smokes. Check for updates, please. Yes, upgrade right now. Do you have notes, fixes? I don't know if that is going to fix my problems. It might make things worse. Who knows? But I am... that is so frustrating. Okay, we get rid of that. Get rid of that. And get rid of that. Golly, this is so frustrating. Ugh. Okay. It is not seeing my camera. My camera is not turning on. Hold on a second. Oh, my camera went out. Jeez. You can't see me either. Well, that's annoying. Maybe if I unplug it and plug it back in or something. Where's that cord go? Right here, this one. Okay, it's powering up again, maybe. Here we go. Okay, you can see me again. Looks like I'm really dark. What happened? Ah! There we go. The exposure switched to automatic, and I don't know why. Okay, my golly. All right, ScreenFlow. Don't mess up on me again, please. Okay, so we're going to record. Do. And we're just going to make sure that it works, because I don't trust you, ScreenFlow. Nope, it didn't work. Boy, good thing I didn't trust it. Ah, this is so frustrating. What happened to you, ScreenFlow? You used to be so good. Okay, it worked that time. What happened to you, ScreenFlow? You used to be so good. Okay, I hope it works this time. My feet are hurting. I need to finish this so bad. We are like 4 videos away from the end, probably, something like that. Okay, here we go. Because we're deploying to the edge and we can only write to a single region, we need to make sure that nothing... Because we're deploying to the edge and we only can write to a single region, we need to make sure that none of the other regions could possibly write to their database. Now, that might seem kind of odd, but Fly has a great mechanism for regions that are not the primary to resend any request that's going to make a mutation to the primary region. So we're going to write some code for that so that we can handle this specific case where we're updating our database. We need to make sure that if we get to this post request, we actually send it back to Fly and say, hey, Fly, I can't handle this. I want you to send it to somebody else because I can't handle this update of the database. Now, there are a couple of ways to go about this. You could just listen to errors that happen, and if the error that happens is a write error, just go ahead and replay it. Or you can add like some middleware based on whatever framework you're using that says, hey, any post request or non-get request should be redirected to the primary instance. However you do it, whatever makes the most sense for you. Doesn't matter too much to me, but the way we're going to do it right here is we'll just have something like this, and await ensure primary, and we'll send the response in here. We'll get the result, and if there's a result, then we'll return the result. Otherwise, we'll continue, and so we'll just make sure that this ensure primary function will return some result that says, hey, you should not proceed. I want you to send this response. So let's come down here. We'll export a function called ensure primary that takes that response. And this is going to be an HTTP server response. And wow, thank you, Copilot. You got pretty close, but we're going to make some adjustments to what Copilot made. We'll import HTTP from HTTP, and we just need the type. And what we're doing is first we get the instance info to determine whether this is the primary instance. If the current is primary, then we just return, and we'll say return null there. If it's not, then we need to redirect the response back to Fly and say, hey, Fly, I need you to send this over to the primary instance. So it's actually not a redirect response to the browser. The browser will never get this response. This will be sent back through Fly, and Fly will look at the response and say, hey, did they want me to replay this? Oh no, then I'll send it to the browser. But if we do, then Fly will stop it from going to the browser, send it to the right instance, and then that instance will send the response. So instead of write head 302, we're going to do a 409, and we're going to specify a header called fly replay, and we want this to replay to a specific instance. And the instance is our primary instance. So we say, hey, Fly, I want you to send this to the primary instance, which can handle this request that's going to happen. And then with res end, we can return true. And also, if you want to, something that I like to do is something that I like to do is to add a console log so that I know that this is happening. We'll say, not that, replaying request from current instance to primary instance. And we'll just add primary right here and current here, just to make that a little bit more clear. So with that in place, we can import that. And we are ready to deploy this to multiple regions so that, and now we're ready to deploy this to multiple regions without worrying about this post request and this database update triggering an error in non-primary regions. In review, the only thing that really needs to happen is that we send a response that has a fly replay header on it specifying the instance we want to replay this request to. Okay. Oh, thank goodness. It worked. Okay, 14, fly replay. Okay, great. So next, let's look at this again. What do we have that is different? Now it's just the candidate thing that we'll need to deal with, and then we will deploy. So here we go. The last thing we need to deal with to get our application ready to deploy to multiple regions here is this candidate configuration. Now, if we go ahead and deploy it to multiple regions, then every one of those regions will think that they are a candidate to be the primary, and they're not. We only want a specific region to be able to be the primary. So what we're going to do is we'll deploy to the SJC region, the one that's closest to me, and then we'll also deploy to the AMS region in Amsterdam, so we get people in Europe. But let's just assume that most of my traffic is coming to me from the US, and so I'm going to optimize their write requests to be a little bit faster, and AMS is just going to have to wait. When it comes down to it, you do have to decide which one's going to have a faster write experience, and the read experience is what most people get most of the time anyway, so it really is okay, and the write experience people kind of expect to take a little bit longer. So the fact is, if we deployed to multiple regions right now, this candidate true would not work out very well because we want to make sure that our primary stays in the US. Otherwise, Amsterdam could take over as the primary, and then most of our traffic ends up with slower writes. So what we're going to do is we'll say fly region equals SJC, and now it's only a candidate if the fly region is in San Jose. With that configuration, let's git add all of the stuff. We'll git commit and say ready for multi-region and git push. And now this will deploy, and as soon as that's deployed, we'll be ready to start adding regions. So in review, all that we did for this one was get us finally ready to deploy to multiple regions by specifying the candidate to be only for those instances that are within the fly region of SJC. So that way we maintain our location for the primary region in a region where most of our traffic comes from. Okay, I was thinking about just continuing that one into, all right, let's deploy this into multiple regions, but I am really happy I did not do that. Candidate. Region. All right, there we go. We've got 15 videos. This one is hard. This is really hard. I don't like this, how hard this is. Okay, so here's our action, ready for multi-region. I sure hope this works. Otherwise, I will be quite sad. Oh, rats. I'm signed into the wrong account. Oh well. Okay, so that deployed okay. We are good to go. Instance is primary, running migrations. Oh, whoops. You know what's funny? I stuck that down here. Okay, we're just going to come over here. We're going to steal that start. We'll stick that right there so we get better stuff. We'll do this as well. So we get a better log there too. And yeah. Okay. So this will be okay. It was just weird that the log came after the action. No pending migrations to apply. Instance is primary, running migrations. Like, that was just weird. So. I wonder why that step is taking so long. Okay, so we will grab this docs because we're going to talk about fly regions. Okay, so where's my text edit pad? Fly vol create data size 1 region SJC. Fly scale count 2. Okay, and then fly vol create data size 1 region AMS. Fly scale count 3. And then we'll be running multi-region. Let's look at our Yep, none of those matter. Okay, and then 12, transactional consistency. That one's tough. Oh my gosh, there's so much code for this. I almost want to publish a library so that I can use it instead of write it all. But I think we should just write it all. Yeah, this is going to be like 3 videos to write all that garbage. Okay. Okay, here we go. our application is ready to go to multiple regions. With all of the work that we've put into it, it's time to go global. So these are all of the regions that Fly offers, and there will be more in the future, I expect. Regions are controlled by volumes when you have a persisted volume for your app. So if you just have a simple Node app that's communicating with other third-party services and you don't need a persisted volume, then you can use the fly regions command. But in our case, we're using SQLite. We've got a persisted volume, so we just need to create additional volumes, and Fly will automatically deploy Node apps to those regions. So we are first actually going to deploy a region to the region we already have. So if we say fly regions list, we already have one sitting in SJC. If we say fly vols list or fly vol list, then we have one volume right there in the SJC region. And what we're going to do is we'll actually deploy another one to the SJC region. The reason for this is so that when we get a deploy, Fly can take down one of those and the other can take over as the primary, so that while this new one is coming up, this one can still serve traffic and we have much less downtime. So that's where we're going to start, and then we can go to multiple regions throughout the world. So to do this, we're going to run fly vol create data. Again, it needs to be the same as what we've configured in our fly toml right here. The source is data, so it's got to be the same name. And with that fly vol create data -- size 1, and then we'll just say region SJC. And with that, now Fly has two volumes in that one region, but we've only scaled our application to a single region. So if we say fly scale show, then this shows us our current scale of count 1. So we only have one instance that can be going on at a time. So to be able to deploy to multiple, we're going to say fly scale count 2. Now this creates 2 instances. And in just a moment, if we say fly status watch with an H, then we'll get another region. No, let me say that again. We'll get another instance coming up on here, and both of these will be able to serve traffic, but only one of them will be the primary. So here's the new region coming up, and if we take a look at our logs over here, then we should see that coming up right now. And let's go ahead and read through some of these logs, because it'd be kind of interesting to see how the primary is selected. So we're starting up. The LightFS version is printed out here using console to determine primary. LightFS is mounted. The server is started, waiting to connect to cluster. And here is the key from LightFS. The existing primary was found. It's 32 yada yada, and we'll see that our existing server was 32 yada yada. So there it is. It found the primary. So it's connecting as a replica. And now the stream is connected. Transaction file for TXID 00001 no longer available. Writing snapshot for SQLite DB. And database, and so this is the part where this new region, this new volume that didn't have a SQLite database came in and said, oh, well, there's already a primary, so let me just basically copy all of the transactions, all of the things that happened to that database. I'll copy it to this one because I'm no longer the primary. So that this is the read replica piece there. So once that snapshot has been updated, now this secondary region is only going to get read replicas. It cannot write, but we can actually hit this particular instance directly. And we'll see our log there that the instance was not the primary, so it skipped migrations. Now the app is started, and we can go to our app. Now, the way that you can make sure that you're going to hit the instance that you want to is you can install an extension like this one, which it allows you to specify some headers, and I want to force an instance ID. So let's get the instance ID of the non-primary region, which I believe was the 9D one. And then we come over here, turn this on, and specify that as our force_fly instance ID. And now if I hit refresh, I'm hitting the non-primary instance. And we can see that down here. I'm going to be amongst all of those health checks. We're going to see a bunch of these at that non-primary instance. And now if I increment and increment and increment and increment, then we'll see a bunch of those post requests going to the non-primary instance, but they don't blow up because we had all of that ensure primary stuff that we had set up. So that's how you deploy to a second region in the same, let me say that again. So that's how you deploy to a second instance in the same region to make sure that with two candidates, let me say that again. To make sure that with two candidates, you avoid as much downtime as the new deployments are coming up. In review, the way that we did that was we first ran fly vol create. Actually, you know what? I'm not ready to review. So here, let me get the status going again. Here we go. So now that we know we can deploy to multiple regions So now that we know we can have multiple instances of our app running, let's deploy to a region on a different part of the world. So we're going to say fly. So let's say fly vol. So let's say fly vol create data. Again, it has to be the same name. Size 1 region AMS to get some of those European friends running our app as fast as possible. And then when that volume has been created in Amsterdam, we can say fly scale count 3. And now Fly knows that we can have 3 instances of our app running. So we can say fly status watch and watch that AMS region come up just the same way as that second SJC region came up. And that one will also work. So let's wait for that to happen. I sure hope this works. If this recording fails, I will be so sad. So that app is coming up. We can take a look at our logs and we'll see that AMS is this FEF. I said it wrong. Is this 4EF, etc. And the logs are very similar to the SJC. It found an existing primary, so it's connecting to that one as a read replica. And now it looks like it's starting to get those health checks, so those health checks are passing. So if I come over here and update my headers to specify I want that region specifically, then I hit that region. You notice it actually took a little bit longer, and that's because I'm going all the way across the pond from Utah to Amsterdam to get this request. And so now if I increment, we're going to get the updated 6, and this is still working even though it has to do the fly replay to get to the primary instance before continuing on back to me. So I can write to any instance and the application's going to handle that for me, and I can read from anywhere in the world to whatever region is closest to me. Now, of course, your users aren't going to have this turned on, and so they'll just default to the region that is closest to them. And for the bulk of the requests that are made on most web applications, it's read requests. And so your read requests are going to be super, super fast, and your write requests are going to be the status quo. And so this is really exciting to have all 3 of these regions running just by creating a couple of volumes in these different regions. Okay, whew. That's good enough. And save that as 16. Multi-region. Okay, so this next one is really, really difficult to reproduce as a problem. Which is a shame. Okay. I've got like 3 videos left. We can do this. This can be done. I believe in myself. Okay. And this is going to be so great. This is going to be so helpful for people. I'm so excited. Okay. Yeah, we're still getting that yellow bar. That is their problem. It's fine. Okay, so now, let's see. We're going to talk about transactional consistency. which is really, 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 really hard to demonstrate as a problem. So what we're going to do then is Excalidraw. I think I've got a drawing of this. Okay, there we go. So we're just gonna, I think we're gonna have one video where I explain the problem, and then we'll have videos where we solve them. We've just created a bit of a problem for ourselves, and I'd like to take a second to explain it using a couple of graphs. So this is the way that fly replay works. The user makes a post request. That goes to the fly router, which is responsible for routing the request to the closest region. So this user is closest to this replica server, for example. So that post request goes to them. We said that post requests can't come to us because we can't write to our database because we're just a read replica. So we send a fly replay to say, go replay that on the primary. So the fly router catches that. It doesn't go back to the user. The fly router just says, oh, you're replaying this. Let me take that same exact post and just send it to the primary. And the primary does the update. As soon as that update happens, then a replication transaction is going to be sent to all of the read replicas all over the world. At the same time, the response is going to be sent back to the user. We don't want to have the user to have to wait until that replication has happened all over the world. We just send the response right away. And so the response goes back to the fly router, and the fly router says, great, let me send that back to the user. All of this works out nicely. The problem is, you might have noticed this arrow doesn't quite make it to the box. So most of the time, this replication is very fast. We're talking hundreds of milliseconds, like 100, maybe 200 milliseconds. Really quite fast. But if the user makes another request and says, hey, you know what? I actually want to make another GET request, a follow-up to revalidate the data I have on the page because I made some sort of mutation. Well, that GET request is going to go to the fly router, and the fly router is going to say, oh, okay, let me send that GET request over to the replica server. That's the one you're closest to. And if this hadn't finished in time, then the response the replica server is going to send back is going to have stale data. And so that stale data is going to make it through the fly router. Router's like, that's fine. And it sends the response back to the user, and the user has stale data. And in fact, it could be that the user just made an update and the replica server doesn't even have that update yet. So the user could type their name as Bob and they still see it as Bobby. So that is not a great thing. And the problem is that this is a very, very difficult problem to reproduce because most of the time, like 95% of the time, this replication happens quite fast. But sometimes it is just too slow. So it's really hard for me to demonstrate that to you, but believe me, on kentcdodds.com, I have run into this problem and it does happen occasionally. So there's actually a pretty simple solution to this, and it is with transaction IDs. So what we do instead is the replica server has a special file on it that says what transaction it is currently on. And so it knows how many, like what number of transaction it is. And the primary server does as well. And so if we could just tell the user, here's your transaction number, and then the user can tell the replica, like, here's my transaction number, then maybe the replica can be like, oh, you have a newer transaction number than I do, so I'll just wait until that replication finishes. So that's what happens here. So instead of the user just sending a request for a GET, when it gets the response back from its post request, the primary server says, hey, here's your transaction number as a cookie. And then the fly router sends that to the user. And then the user sends that cookie as the follow-up GET to say, hey, I need some revalidation of my data. That GET goes to the replica server with a transaction ID. And then the replica server just says, oh, you've got a transaction ID. Let me check mine. Oh, mine is older than yours. So let me just like make you wait just for a second while I wait for that replication to finish. And when it is finally finished, then it can send the response with the latest data, and everything is hunky-dory fine, no problem at all. This solution is a little bit complex, and there's probably some library hiding in here that maybe one of you can write or you can find. But for the next couple of videos, I'm going to show you how to create this library. And it's really not a ton of stuff, and it's not very intrusive on your code base, but it is a very pretty elegant solution to a very difficult problem of consistency and availability when you're trying to make your data and your node applications distributed to the edge. So I think that you're actually going to enjoy this a bit, but buckle up, there is quite a bit of stuff that we have to do here. Okay, yeah, I'm fine with that. That works just fine. So we will save that. 17. Consistency explanation. That is not how you spell explanation. That is. Okay. Great. So let's implement this solution. Okay. By golly. I cannot. How long have I been streaming? 5 hours. Goodness. Okay. So we're going to be hanging out in the app. And the first thing that I want to do is write the get transaction number. Yeah, so where's my notes? I had notes. So 1, get TX number. 2 is the challenge is you can't even test this very well. Like, running it locally just doesn't work. So you just have to like write it out and hope that you got it right. It is really quite hard. This is very difficult. Okay, yeah, I think we'll start with the usage. Call handle transactional consistency and set tx cookie. And then we'll write get tx number. Whoop. Right, get tx number. Yeah, I'm glad I'm planning this out. This is going to be a lot better than I was kind of thinking. I'd just shoot at the hip. Oh no, we're going to write set tx number, right, get tx number, or set tx cookie. Should probably be consistent in my casing. Yeah. Okay. Right, append header, or we'll just copy that. It's just a silly utility that most people won't need. Use cookie, serialize. Okay, yeah, so that's all writing the set cookie header and then set tx number. And then, so we'll just get rid of that. And then we need to write handle transactional consistency. Which will involve writing. I don't know if you can hear my stomach, but I'm really hungry. Write for up to, or wait for up to date TX number. Okay, so we're going to move this down here, and we'll do all of this here, and then we'll call that, write that, and write that. That's going to be a fair bit in a single video, but I think we might split this up. Yeah, we're going to do that. Okay, so that's how that's going to work. So first, call set tx cookie. There's an airplane again. Set tx cookie. That happens after the post. And then we write it. So I kind of want to have that. Yeah, that's fine. We'll just put it up here. Okay, here we go. The first part of solving this problem is to make sure that after we write anything to the database, we set the transaction number in the user's cookie. So actually, you know what? It might be useful to have Excalibur up so we can talk about what step we're working on. Yeah, that'll be handy. Okay, let's try that again. The first part of this that we're going to handle is making sure that the response the primary server sends when a post request comes in has the set cookie to have that transaction ID. So that's going to happen in here with set tx cookie, and we'll pass the response so that it can add that cookie header. This is going to be async, so we'll just await that. And let's come over to our fly to write that function. It's a function called setTXCookie. It takes the response, which is an HTTP response. And then, nope, don't let that show. And then we'll get our TX num from await get TX number. Now, this function is going to be a little bit tricky. Don't let that show up. I just needed to get over here. And don't let me say it's going to be a little bit tricky. So just back up a little bit. Now, for this function, it's going to simply read a special file that Now this function needs to read a special file that Now this function is going to read a special file that lightfs writes to the file system to tell us what the current transaction ID is. And it writes it to the lightfs. Oh, you know what? Actually, we should just look into it. And we can take a look at that by going fly ssh console c bash, so that we can console into one of our running VMs, and we can cd into the lightfs directory. And if we lsal right here, then we see we have that .primary file. We also have the SQLite db-pose. If we cat that SQLite db pose, then we see this is what it looks like in there. The first half of this is our transaction ID encoded as hexadecimal. So the convention for this is that it goes into the lightfs directory, which we configured here as our dir for fuse. So it'll go into the fuse directory. And then the name of the file matches the name of our database, which we configured in here to be SQLite DB. So what I'm going to do is I'm going to make another environment variable called env database file name. And we'll set it to SQLite DB and then put it right there. So it technically is unchanged, but I like to make those relationships explicit by having that environment variable. Okay, don't let me change to that file. That was, or no, that is the right file. Yeah. And now I can get that environment variable from process env. So we're going to need both the lightfs dir and the database file name. Please clean up that typing. One thing that I'm going to do though is another thing I'm going to do is I don't want any of this code to run when I'm not running in fly. So I'm going to simply add if not process env.fly return 0, and then I'll add that as an environment variable here. So we'll say env fly equals true. Okay, we're just changing to this one file. There we go. So now we don't have to worry about this transaction number. So now we don't have to worry about attempting to read this transaction number unless we're running in fly. Great, so let's also do an invariant on both of these to make sure that they do exist, and if they don't, we'll get a nice error message about that. And then we'll let the db pose equal just simply 0, and then we'll try to read that file. The db pose should equal read file of the lightfs dir and the database file name as UTF-8 encoded. And if there is an error in doing that, we'll simply ignore it because we defaulted our db pose value already. And then simply return parse int db pose. Because it's hexadecimal encoded, it is 16. But again, it is a combination of two values, so only the first of which do we care about. So we're going to trim this and then split by the slash, grab the first one, and if for some reason that doesn't exist, we'll just take extra care that it defaults to 0. So now with that get transaction number implement, oh man, try to make it so I'm not scrolling around so much if you can. So now with that get transaction number implemented, we can set the cookie. So let's get our const cookie, and the cookie actually can be serialized by a special module with a very nice name, cookie. And with that cookie module, man, hold on a second. Let's back it up a little bit to that spot where I said, please don't make it scroll around. Just do your best to make it look not so bad. I think it was right here or somewhere around here. So now let's go ahead and get our cookie value from the serialized version of this value. So let's import cookie from cookie. And then we'll say cookie.serialize the txnum to be txnum.toString. And we'll configure things a little bit. So we'll say the path is just the whole app. It is HTTP only, same site lax, and secure true. All of that sounds good to me. And then we need to set this on the response. The problem is that the response, if we call set header, will override any other headers, will override any other set cookie headers that are in existence. So we actually need to make a special function just for us called append header. And this is going to take a res, which is an HTTP server response, the name, which is a string, and the value, which is a string. Don't let Copilot jump in when I don't actually use it, if you can. And we only need to write this function because we're not using Express or anything. Most frameworks have a way to append a header. It's just kind of annoying we have to bother with this. So because of that, actually, you know what? Let's back this up. If you can, I don't know, my scroll is going to mess up things really bad. So I'll just start scrolling, and you can make it look like I started scrolling or something. The problem with this set header is that it's going to override other cookies that we're trying to write through the other data. And let me say that again. Let me copy this too. Okay, here we go. We're going to try this again. The problem with this set header function is that it would overwrite any other set cookies that other parts of our code we're trying to write. And this is supposed to be a little transparent. So I don't want to override those. I just want to append one. And if we were using a regular web server framework, then we would be able to simply append header. But since we're just using HTTP, I just happen to have this handy little utility function called append header that we can use to append this header. So instead of setting it, we can just simply append an additional set cookie header. And with that, now all of our users are going to get the transaction ID set as a cookie in all of the responses to their post requests. So that on the next request that they make, we can reference that transaction ID and make sure that we have a transaction ID that is at least as up to date as the one that they have. In review, the way that we did this was we created a database file name environment variable. We also created a fly environment variable to make sure that we don't even bother looking up the transaction name if we're not running in fly. We looked up the special file. Oh shoot, that is wrong. So I'm glad that I reviewed. Let me just double check that yeah. We look up the special file, which we'll find in the database name with a -pose at the end. So it's a good thing that I noticed this. We need to add that as a -pose at the end of this file name. And that will give us the transaction ID on the left side of this slash. Okay, 1 second. I need to remind myself what the other side is. So let's see if I can manage that without making it too hard to edit. Light FS getting started, or nope, light FS getting started. Here we go. And then it's special files. Yeah, replication position. Yeah, okay, so that's the checksum. And the right side of that slash is the checksum for the current contents of the database that is used by LightFS. So we simply extract that left side of the slash and parse it into an integer from its hex encoding. Then we use that transaction number to create a cookie and append that as a set cookie, so the client will get that cookie and send it with its next request. Okay, sweet. That could have been worse. It was quite long, but I think there's plenty to cut out. Maybe, hopefully. Okay, get tx number. Okay. All right. Yeah, I probably shouldn't have wrapped it like that. It doesn't make a difference actually, so it's fine. But we're going to change it to that. Okay, and then okay, so then call handle transactional consistency, and that happens at the top. And we can get rid of that. Happens at the top right here. Okay. Here we go. Now that our clients are sending us their transaction ID, we need to handle that to make sure that we wait until we have a transaction ID that is at least as up to date as theirs. So inside of our create server, we're going to make sure that we handle that transactional consistency. We're going to get the result, and we're going to await handle transactional consistency with the request and response. And if there's a result, then we'll send the result. And now in here, we'll make another function, export a function called handle transactional consistency that takes the request, and that's an HTTP request. I forget what it is. Incoming, yeah. Here we go. Incoming HTTP, no. Incoming message and a response, which is an HTTP server response. And with those, now I want to do a couple of things to just exit early if we don't need to bother with handling transactional consistency. First of all, if we're not running on fly, then we'll just go ahead and return early. If the method that is being, if the request method is not a get or a head, then we're probably fine just continuing on as well. So we'll say rec method is not equal to get, or and the rec method is not equal to head, then we're fine to return null here as well. Because we only care about when they're going to read data. If they're going to write data, they probably should have the latest up-to-date stuff already, and that's fine. Now we need to get the request cookie from the rec headers cookie, and the cookies rec cookie is cookie.parse to turn that into a useful object for us. So then we can say if there's not cookies.txnum, then we can simply return null for that as well. And you know, I don't feel super comfortable having these two values being so important and not being explicitly tied. So we're going to make a new variable called the txnum cookie name, txnum, and we'll reference that in both of these places. Great, so now that we've determined we actually care about this particular request, let's determine whether we're currently running on the primary, because if we are, then we can get rid of that cookie header and not worry about it. So we'll say const current is primary, and see if Copilot can finish that for me. Thank you, Copilot. And if the current is primary, then we can simply append header. Don't let that cursor show up. Onto the res with set cookie, and we're going to delete that cookie. So cookie serialize that particular cookie to an empty string, and then set the path to / and expires to a new date of 0. And that will clear the cookie for us. So if they're making a GET request to the primary, they don't need to have this cookie at all. Otherwise, if we're not the primary, then we need to wait for the updated TX number. So let's get the TX. So we're going to wait for that. Wait for up to date TX number, and we'll pass. No, I don't want that. And we'll pass the numbered version of cookies txnum cookie name. What is that red underline complaining about? Okay, I'm just going to hover over that and see what it's, oh, cannot find, yeah, that's fine. And then once that's finished, we can go ahead and clear the cookie. And the user can be on their way. Actually, you know what? Let's do this instead. Okay, back that up. Pretend that I just hit save. That should be okay. So I just finished with the append header. I just hit save, so things jumped around. If it's not the primary, then let's go ahead and borrow some of the code from here to replay to the primary instance, because we clearly can't because we don't have the latest up-to-date stuff. So we'll just simply send, So we'll just simply send this as the response. And now we are handling transactional consistency. Although it's not totally optimal to have to replay the request over to the primary all the time, again, this doesn't happen all that often. Oh, hold on a second. No. This isn't going to be enough. Oh, man. Okay, go back. Back. Okay, so I just hit the save button, and my cursor is, actually, I wonder if I can figure out where my cursor was, so that it's easier for you to cut this. I'm sorry that this was a bit of a pain. Okay, so right here I hit save. Boom. Okay, so you jump to this. I'm not sure where my scroll position was, so I'm sorry, but I think it'll be okay. All right, if we're not, and if we're not in the primary, then let's check whether our txnum is equal to, oh man, that's so annoying. Oh no, that's okay. Okay, get rid of that so annoying thing, and we'll just walk through this code. Then we'll just get our txnum, and oh, thank you, Copilot. So we'll get the tx number, and if the tx number is greater than what shows up in the cookie, or equal to, if they are, no. Actually, Copilot, if the txnum is less than what is in the cookie, then we will replay it to the primary instance so that the primary instance, which has the most up-to-date data, can handle this request. Now, this isn't perfectly optimal, but again, this is very rare that the tx number will not be as up-to-date as what the user has, because this replication normally happens very fast. But this will cover us in the event that that does happen, and the user will not have to experience some data consistency problems. Yeah, okay, that's good enough for now. So we're going to just do a review. In review, what we did here was we added this handle transactional consistency at the beginning of our server. So this would be like a middleware if you're using Express or something like that. At the very top, you just double check, hey, let's make sure that we're going to be transactionally consistent here. And at the top here, we make sure that we're running on fly. We make sure that this is a GET or a head request. If it's anything else, then we really don't care about transactional consistency. We grab the request cookies and parse those. And if we don't have a cookie by the txnum cookie name, then we don't bother. We just continue with the request. And then we get the current instance info, and if the current happens to be primary, then we can just get rid of the cookie and it's no big deal. Otherwise, we'll get the transaction number for this current instance, and if that transaction number is less than what the user has, then we're going to replay that request back to the primary, so the primary, which has the most up-to-date information, can handle that request. Okay. But this is not where it stops. No, because we can do even better than sending them to the primary. Handle consistency, transactional consistency. Okay, video 12, or 20. Yeah, that's a lot more than 12. Okay, let's see what we got left. Okay, so then we have to wait for it to be up to date. as I've said, this doesn't really happen all that often, but it does happen enough that you want to have this code in here. But if it doesn't happen all that often, it's only because replication is actually quite fast. And so sending the user back to the primary is going to add a couple hundred milliseconds potentially to that request. And if we only just waited like maybe 50 milliseconds, then we could have responded from this instance if we just waited for that replication to finish. And so what we're going to do is we're going to grab this value here and call this the session TX number. So this is the TX number for the session of the user. And then we're just going to wait for just a little bit. Maybe we'll time out after half a second or something. But we'll just wait for a little bit before sending them this replay response, because if maybe our transaction ID gets updated, then we can just send them the latest stuff from us, which would be much better. So I'm going to make a function down here called wait for up to date TX number, and we're going to get that session TX number, which is a number. And then first we're going to say our current TX number is await get TX number. And if the current TX number is less than, no, try that again. And of course we need to make this an async function so that we can use await there. So then we'll say if the current TX number is greater than or equal than the session is greater or equal than, sorry, fix that please. Well, I'll fix that. Here we go. So then we can say if the current TX number is greater or equal than, or equal to. So then we can say if the current TX number is greater than or equal to the session TX number, then we can just return. We don't need to wait. We're ready. We're set. Everything's good. We'll just return true. We don't need to wait. Otherwise, let's determine a max waiting time of 500 milliseconds. If it's going to take longer than that, we probably just should have sent them to the primary to begin with. And then let's determine our stop time. So date.now plus the max waiting time. And then we're going to sleep just for a little bit. So let's make a sleep utility here. That's going to take some number of milliseconds and resolve a promise after a little time. And we're going to sleep, let's do 100 milliseconds, maybe 50 milliseconds. And we'll do while, sorry, I don't want the cursor to show up there, please. While the current TX number is greater than or equal to the session TX number, and date.now is less than the stop time. That's wrong. Copilot was right. So back that up, sorry. And I'll just use Copilot. While, oh, thanks Copilot. Yes, while the current TX number is less than the session TX number and date.now is less than the stop time, we'll continue to do this. And what are we going to do? We're going to sleep for 30 milliseconds. And then we're going to assign the current TX number to get TX number. So we'll read the file again to check what the current TX number is. And then if we get to the end of all of this and the current TX number is greater than the session TX number, then we can simply return true. Otherwise, we'll return false. And this is the case that is pretty unlikely to happen, but I have definitely seen it happen on my server, so this code is worthwhile. So now, with this wait for up-to-date TX number, we can say await, wait for up-to-date TX number, and we'll get, and as a response, we get the TX number is up to date. So that is a Boolean. So if the TX number is up to date, don't let Copilot jump in, then we'll simply clear out the cookie, just like we would if we were on the primary. Otherwise, we'll do all of this stuff. I mean, I don't want to say all this stuff. Otherwise, we'll send a replay. Otherwise, we'll send a replay. There we go. That's better. And with all of this in place, we're now safe to exit this, to git add all of the stuff and commit transactional consistency. And then, unfortunately, because this is so hard for me to reproduce, I can't prove to you that it works, but you'll just have to believe me. This does happen, and it's worth taking the time to solve. So in review, what we did here was we did a little bit better than just replaying if the transaction number isn't up to date. We parsed the value. Oh, we parsed the value from the session. No, we parsed the value. We parsed the user's transaction number, and then we called this wait for up-to-date TX number, which will double check that the user's TX number is, which will check whether the instance's TX number is greater than or equal to the user's TX number, and if it is, it just returns true, no need to wait. Otherwise, it will wait for the current TX number to be greater than or equal to the session TX number, and if that never happens, then we'll return false and the replay will happen. And this allows us to get the best of both worlds. We can have both transactional consistency as well as availability and resiliency for our edge distributed. No, let me say that again. And this allows us to have the best of all worlds. We get edge deployment with our node server and our SQLite database on the edge distributed to multiple regions, and we can ensure transactional consistency so users never see stale data when they're making a request to a server that hasn't yet gotten the data replicated to it. Whew, okay. Yeah, that's fine. That was just fine. All right, 20, and this is wait for TX ID. Okay, great. Good grief. I sure hope that I got all that right. It is deploying. There's not really any reason for me to show this in the videos, so I'm not going to bother. Actually, you know what? I am going to bother. I'm going to add this to the end of that one. Let's just wait for this. And there's that txnum. And that's where it clears it. Okay, yeah, we're set. Okay, let's just add this. And to see this in action, we can go to our site, open up the DevTools, and do a mutation. Then we look at that post request and we'll see it's calling setCookie txnum21. And then in the follow-up GET request, we'll see setCookie txnum equals nothing with an expiration in the past so that it clears out the cookie. It happens so fast you won't even be able to see those cookies inside of the application menu. Okay, and I think the best place to put that would be, here I can bring this over so y'all can see that. I don't even know if anybody's watching on a Saturday, my goodness. Probably like, go enjoy your family, you loser. Yeah, that would be good. Just really want to finish this. I just realized I need this up here. Okay. And then, unfortunately, because And then, so in review, there we go. We'll just not say any of that. I'm very curious why when I record and add it to an existing scene, why it sticks my video in the middle. Transactional consistency. And to see this in action, we can go to our site, open up the DevTools, and do a mutation. Then we look at that post request, and we'll see it's calling setCookieTXNum21. And then in the follow-up GET request, we'll see setCookieTXNum equals nothing with an expiration in the past, so that it clears out the cookie. It happens so fast, you won't even be able to see those cookies inside the application menu. So in review, what we did here was we did a little bit better than just read. And this allows us to get the best of both worlds. All right, there we go. Okay. And I guess I'll just record a final goodbye or something, which probably won't have a background of anything, but if it does, I guess. There we go. I hope you had a good time learning how to try that again. I hope you had a good time learning how to deploy I hope you had a good time learning how to deploy a Node.js app with its data on the edge. This is long-running server stuff. You can do so much awesome stuff with this technology. Let me see. Try that again. I hope you had a good time with me learning how to deploy a long-running Node.js server and its database on the edge with Fly.io. This is really exciting technology that will allow us to make really awesome user experiences for users wherever they are in the world. And even though it does take a little bit of work, I think that it's worth the effort. And thank you so much to Fly.io that makes this so much easier than it could be alternatively. The future is on the edge, and I'm glad that you're here with me. Okay, yeah, that's good. Okay. All right, so now what I get to do is export these videos. Good night, nurse. Here we go. Okay, so I spelt instance wrong. Uh-oh. I hope it wasn't ever in a place that mattered. Great. Counter app. Where did I spell instance? Where is that? I'm not seeing where that is. That message was sent, oh, just a second ago. Okay. So hopefully you're still watching. Where did I spell it wrong? Please tell me I don't have to re-record stuff. Okay, so the way that this is going to work. Hey guys, thank you so much for editing these videos for me. At least I was making the right trade-offs for my application because in a lot. Okay, I'm not going to optimize the audio and stuff. I'll send them exactly what I got. Okay, so we're going to man, I wish I could do a batch export of this or like add stuff to a batch export. Okay, so what we're going to do instead, to make this much easier for me, face. Oh, I need 22 more steps. There we go. Okay, so you all can see this, that's fine. So these ones will all just big screen my face. Okay. Scale to fit. Okay. I don't know why it went over there, but scale to fit. Okay. Scale to fit. Yeah, scale to fit. Make sure that all looks good. This is just a voiceover, don't worry. Okay. I can sit down now. Hallelujah. You know what would be really sad is if I had to re-record any of these. I'm almost positive I am going to have to re-record some of these. I don't know why it opened over here, but it did. Okay. There are so many videos. Good grief. Uh-oh. That is... Oh my goodness. I'm blurry. What? Oh my gosh. Ah. So from that moment when I had to restart my camera, it went out of focus. Ah. Oh no, that's so bad. It looks so bad. Oh my gosh. Dang it. Okay, I need to make this big so y'all can see, or so I can see it better. See, that's how blurry it is. Oh, that is not good. I blame ScreenFlow for being so unreliable that I had to restart stuff. That is the worst. Oh, shoot. Well, Oh, dang it. So when did it get bad? It was okay there. It just got bad starting here with all the really hard stuff. Okay, not especially hard, but I'm gonna have to say I can't do it. So they can use that and just have me in the corner or something, or don't use it at all. But I will re-record the outro, because that definitely is going to be just my face, basically. But, oh, man. That hurts. Hurts real bad. I mean, if I have to, I'll do it again. But gosh, that is so frustrating. Okay, and then we're going to redo the outro. It does, I guess. I hope you had a good time with me learning how to deploy a... Here we go. Now that it's not so bad focus, let's try this again. I hope you had a good time with me learning how to deploy a long-running Node.js server with SQLite database distributed on the edge as close to your users as possible. I'm really excited about the technology that we have available to us now to give our users the best possible experience with our applications. And I think that you're really going to enjoy hosting your server. I sound like a salesperson for Fly. I'm not. I just like that. Let me try again. I hope you had a good time learning with me how to deploy to the edge with Fly.io. Deploying long-running servers and your data as close to your users as possible. It just blows my mind what we have available to us, and getting the best of all worlds. We have availability, we have data consistency with the transactional consistency stuff that we did. It's really cool what we've been able to do. So I look forward to hearing about the cool things that you're running on the edge, and I'm so happy that you're with me. Okay, that'll be good. That'll be fine. All right. Now, how does that look? Yes, way better. Good glory. Okay. So this is going to override that. Replace. And yeah, we'll just delete that one. Okay, cool. So then on these ones, we just hide the face. Get rid of that. Whoops, definitely want to be able to see something. I don't know why some of them go over here. That doesn't make sense. Okay. Oh, I can sit down again. Oh man, I recorded like this. I think I may have chopped off part of my head. Oh, that is not the one I wanted. Yeah, I think part of my head is... I I hope you had a good time learning with me how to deploy to the edge with Fly.io. Deploying long-running servers and your data as close to your users as possible just blows my mind what we have available to us. And getting the best of all worlds. We have availability, we have data consistency, transactional consistency stuff that we did. It's really cool what we've been able to do. So I look forward to hearing about the cool things that you're running on the edge, and I'm so happy that you're with me. Okay, that's close enough. That's fine. Also, it means that you see more of me, so that's like, I guess that's a good thing. Maybe, I don't know, maybe that's not a good thing. Okay. Okay. And it just occurred to me this probably makes more sense to go in there. Okay, here we go. So I'm going to add face to the end of all these because I think the batch export is going to just use the file name. You know what? I could probably copy. That's a lot faster. Whoops. Unless I do that. Okay, cool. So now, screen flow, we're going to batch export. And we'll choose all of these and all of these. And this will go to Dropbox. Whoa. EpicWeb tutorials deploying source video. Okay. And here we go. Okay, cool. With that running, I'm going to leave that running for however long it takes. And I am finally done. Holy smokes. Let's see, my score, 715 for centered. Booyah. All right. Hope you all have a wonderful evening and weekend and all that. And I'm going to go. And I'm going to just chill with my family now. So thanks for hanging out with me, if you hung out with me. And we'll see you all in the future. Bye.